DebateCon 7 will be in Houston, Texas on Saturday, January 31st, 2026, and featuring some of your favorite debaters that you can come out and meet and see debating live, including David Wood, Daniel Hakikachu, Inspiring Philosophy, Mike Jones, and more. Check out the tickets right now in the description box. You don't want to miss it. We're expecting it to sell out. Grab your tickets now. Hey everybody, tonight we were debating Flat Earth versus Globe Earth, and we are starting right now with William's opening statement on behalf of the Globe. Thanks for being with us. William, the floor is all yours.
Thank you. Let me share my screen here.
And folks, there we go. Perfect. And we're ready for you.
All right. Let me set my timer. All right, let's get started. So my name is Free Will. I'm an engineer. My degree is in engineering physics, and my specialization was in spacecraft systems. I've studied orbital mechanics and spacecraft design. And today, I want to take the opportunity to describe and explore the differences between the two models, the globe model and the flat model, and what they predict, and how that compares to what we see in reality. So let's get started. So the first evidence that was gathered about this was from Eratosthenes over 2,000 years ago. Essentially, we know that if the Earth was flat, that there would be an asymptotic trend of shadow angles over the latitude of the planet. And if the Earth was spherical, there would be a linear trend of shadows across the latitude of the planet. And it turns out, after measuring it, we do have the linear trend of shadows across the surface of the planet. We see, on a flat Earth, you would never see a 90-degree shadow, and on globes, we see 90-degree shadows near the poles all the time, and even not at the poles, you see 90-degree shadows at sunset every day. So we know that would only be relative to a globe Earth, so that wins on the globe side. For star movement, for a globe, we know that if you were standing on the equator, you would see a straight line of stars going across your head, straight across your head, and you would see a circle of stars going around a pole on the north side of yourself, and stars going in a circle on the south pole side of yourself if you're standing on the equator. And that differs from the flat model. If you were standing on the equator, you would not see a linear path of stars going across your head. You would see a curve of stars going across your head, going around the North Pole. And there would be no South Pole that you could point towards. It would just be stars going straight around that area of the sky. So that is a clear, stark difference between the globe and flat observation. And what do we see every day? We do see stars going in a straight line across your head at the equator. So that's a win for the globe as well. Planet movement. If we were on a planet and we were orbiting a star, we would predict there would probably be other planets orbiting the star, and we would be able to observe those other planets from our perspective. And we would see specific movements from our perspective that are very identifiable, especially one called retrograde motion. This would be very clear. This is a direct prediction based on orbital mechanics. And what would a flat earther say about movement of planets across the sky? They would say, I don't know what planets are, I don't know why they're moving, I don't know how they're moving, and I can't really predict where they're going to go either. So which of these models has better predictability? The globe model has better predictability. Lunar eclipses. If we were on a globe, we would predict that eventually the globe would obscure the sun that illuminates the moon, and it would project a shadow onto the moon, and that shadow would be circular every time because we're on a sphere. The penumbra and the umbra would be circular, and we could not only predict it would cast a shadow, we would predict when it would cast a shadow and where it would be observable from the Earth, down to the second. That would be true if we were on a globe. But if we're on a flat Earth, there's really no explanation of why there's any kind of lunar eclipse. That wouldn't really make sense in that model. And there's not really any logical reason on a timeline either. You wouldn't be able to predict when or where they're going to happen or why they happen. So which one has better predictability? The globe does. That's definitely a win for that one. Constellations. On a globe, In the South Pole, you'd predict if you're on point D on the South Pole or point E, as you can see, you would be able to see the Southern Cross. It doesn't matter what side of the South Pole you're on. But if you're on the flat Earth, if you're on point D, maybe you could see the Southern Cross. But if you see it there, then it wouldn't make any sense for you to see it on point E, right? Because it's on the opposite side of the flat Earth. So what would you see there? I don't know. Nobody knows because they don't really give any more information than that. So can you see the Southern Cross on point D and E? The answer is absolutely. That is very consistent with naval observations. Win for globe again. Flight times. These are 2 flights that I took from flightaware.com. I encourage everyone to go do it. Flight from Seattle to London went about 6,500 miles and took about 10 hours. And the same is true for a flight from Chile to New Zealand. It was about the same length and about the same timeline, which is what you expect on a globe because it's about the same distance and about the same time. However, on a flat model, it completely turns out on its head because it is about 3 times the distance if you use this type of a flat Earth map. I can't even tell you the exact time it should be because on a flat map the geometry doesn't really make any sense. But you can clearly see it would be 3 times the length, therefore should be 3 times the time it should take to fly that distance. Is it 3 times the time? Is it a 30-hour flight from Chile to New Zealand? No, it's a 12-hour flight, not even close. So another win for the globe. And again, that's from flightaware.com, public information, thousands of data points every day. Please take your fill of those data points and run your own experiments. Coriolis effect. The globe has a Coriolis effect. The reason it has a Coriolis effect is because when it is rotating, the wind at the equator is moving very fast, and the wind at the pole is not moving as fast because it's a smaller radius from the axis of rotation. Therefore, you would have a different rotation direction for hurricanes in the north hemisphere versus the south hemisphere every time. And not only would it be different, those hurricanes could never pass the equator, because if they did pass the equator, they would start rotating in the opposite direction, and therefore they dissipate and just stop being hurricanes. That would be true if you're on a globe. That's what it would predict. On a flat Earth, there should not be any Coriolis effect at all, because it's not rotating. However, let's say the sky's rotation around the stationary Earth does have an influence on the winds that are underneath that sky. So it does cause some wind from the sky's rotation. Then there would be a Coriolis effect. However, that Coriolis effect would be the same for the north hemisphere and the south hemisphere of that flat Earth. There would be no difference between the hemispheres. So the hurricanes would all spin in the same direction. Is that what we see in reality? What kind of hurricanes do we see in reality? We do see the globe prediction. They do spin in different directions, and no, they never ever cross over the equator. This is my last slide for the hard evidence. This is my favorite one. It's for gravity because it basically is helpful in predicting so many things. This is a list of a few of them. Number 1, we can predict the results of the Cavendish experiment. We can predict the motion of projectiles in every category from baseballs to nuclear bombs. You can use gravitational equations. You can predict the outcome of the Foucault pendulums, of how they move. You can predict the outcome of the Heffel-Keating experiment. You can also predict that we would have an atmosphere, because although atmosphere is very low density, an atmosphere is made of atoms of gas, and those atoms have mass, and mass is attracted to mass with gravity. So it would still cling to the very massive object, which is the Earth, in the vacuum of space. You'd predict the tides of the ocean using gravity, because the tides of the ocean is a influence from the gravitational effects of the moon around the planet. You'd predict optical lensing observations that you would see from deep space, which is a result of modern relativistic theory from gravity. You could also predict the shape and motion of not only the Earth, but the moon, the sun, all comets, all asteroids, all planets in the solar system, and all stars in the galaxy, and all galaxies in the universe using gravity and gravitational equations. It is the most validated concept in all of science, and if you are denying its existence, you're basically a fish denying the existence of water. So what can flat earthers do when it comes to this kind of phenomena? they have nothing. They can't predict these types of things because there is no set of equations that are going to be logical as a result of physics for that. Now, why is flat Earth a thing at all? Why does it pop up every once in a while as... Because we disproved this thousands of years ago, literally thousands of years ago. So why does it come up at all? I just want to talk about that for a second. It's for two main reasons. Number one, it's hyperskepticism. And hyperskepticism is bringing skepticism, which is a good thing, beyond the point of usefulness. Hyperskepticism is when you are so in fear of being misled that you will not trust anybody for any reason. And this is bad because you won't accept any support, knowledge, or evidence from any reliable sources that would be helpful to you. It is also a product of misinformation spreading. And the reason that happens is because people profit from attention, even if it is in the name of false information, and that's especially a problem with modern day social media. It prioritizes interesting, exciting ideas rather than true ideas, and that's why these kind of ideas spread over time. And that's it for my time. I have more slides, but I want to present them during our conversation. So thank you, Iron Horse, for being here.
Thank you for that opening statement. We are going to kick it over to Iron Horse for his opening as well.
I can't hear you, James.
Oh, that's right. I'm muted on Zoom, folks. That's why. So, thank you very much for that opening. It is going to be a big, beautiful debate. We are going to kick it over to Iron Horse, but first I want to let you know, folks, about a couple of housekeeping things here, okay? Very important stuff. First, if you have been living in a cave on Mars with your fingers in your ears and you didn't know about DebateCon 7, which is right behind me and to the side of me, it is going to be huge. On screen, you can see that the bottom right of your screen is going to be in Houston, Texas on Saturday, January 31st. We expect this to sell out. Grab your tickets now. In fact, not only that, but early bird tickets are going away tonight at midnight. So if you've been thinking about it, grab your tickets now. Get them at this discounted early bird price. It's going to be an epic conference, 4 heavyweight debates. You don't want to miss it. With that, we're going to kick it over to Iron Horse. Thanks for being with us. The floor is all yours. Let me check if you're muted. Sorry about that. I'm even going hard on the mute. Oh, I just asked you to unmute. This is my fault. It's amateur hour over here. I don't know what I'm doing. So there you go. You're good.
Oh, good. I thought I unmuted myself. I was going to make a presentation, but of course I ran out of time. So all I've got is a written word. And I've written, well, greetings to all. Thanks, James, for hosting. Good luck to my opponent, William. And please enjoy, fellow stationary planar earthers. The ultimate pursuit of knowledge is ultimately the search for the truth. Truth isn't necessarily something we find with proof as such. Rather, it's the elimination of all that is absurd or impossible until what remains, no matter how unlikely, must be the truth. Throughout the ages, mankind has pondered all manner of philosophical musings, such as who we are, where we come from, where we go, and while we're here, well, where are we now? And this is the topic of today's debate, which after thousands of years of investigation and discovery has been fine-tuned into 2 competing schools of thought. Those of us who believe we live on a physical, topographical, terrestrial plane fixed at the very base of the universe, and those who believe we live on the outer crusted surface of a massive molten spheroidal organic spaceship with over 70% self-contained miles-deep bodies of curving water twirling and whirling through a vacuum of space, orbiting the sun at a speed that would leave an electromagnetic railgun projectile appear slow. Or to abbreviate, we have the saying flat earthers, or stationary planar earthers, versus the deluded spinning spaceballers, the heliotards. It should come as no surprise that the spinning spaceballers are the most ignorant about their own belief, their own model, the history of how it came about and why. But they're quick to make bold, unfounded claims such as all the evidence points to the oblate spheroid Earth, or the notorious, we've known it's a sphere for thousands of years, as though this is supposed to add credibility to their ancient superstitious belief. In fact, the biblical flat earther will declare over 200 different quotes from the Bible in support of a domed stationary planar Earth, starting with Genesis and creation itself, when God created a firmament to separate the waters above from the waters below, matching the known physical properties of water, always seeking its level. Yet the spinning spaceballers dismissed this claim because the claim is thousands of years old, failing to see the irony in their chosen form of dogma from the same era. And if we analyse what their Gospel of Globetardia has to say about their spherical Earth that they've known about for thousands of years, check this out. It was unmoving, geostationary at the centre of the universe. It sits on the shoulders of a giant as the sun god Apollyon carries the flaming sun across the sky in the back of his golden chariot, pulled by 4 mighty steeds, before descending into the underworld to wrestle with the giant serpent all night long. The wandering stars were called planetae, from which we derived the modern word planet, but back then they were other gods and deities, although even Zeus, or Jupiter, had to submit to the all-powerful Ra of the sun. So while the spinning spaceballers of today say they've known for thousands of years, the facts state that it wasn't until 1543 that the works of Jesuit occultist Nicholas Copernicus, who proposed a thought experiment whereby that if the Earth were a wandering star like the other planets, going around the stationary sun in the centre of the universe, that the concept of a spinning spaceball even began to exist. Copernicus himself actually thought the idea impossible and ludicrous. However, he was strongly encouraged at the time by Pope Paul III to work on the concept. This opens the massive rabbit hole as to why they would do it, probably best saved for another debate. Today I'm going to list several topics and compare them to each model just briefly, and my opponent is welcome to choose any one or another of his own choosing to discuss in more details, as I simply won't have time to mention the 1001 things I'd like to. I'll start with major rivers, for example, some that are thousands of miles long, such as the Nile, the Mississippi, or the Amazon. The Nile, for example, starts at Lake Victoria at an elevation of 3,724 feet, a little over a kilometre above sea level. And as the world's longest river, flows some 4,132 miles, or 6,650 kilometres, until reaching the Mediterranean Sea. On the stationary planar Earth, the water simply flows from one level to the next, filling and taking the shape of each container until finding one edge lower than the rest, and so on it flows into the sea, the level above which all dry land and topography is measured. In fact, for about the last 1,000 miles, there's a mere drop of just 6 feet. If we're to represent just this final 1,000 miles on the spinning space ball, for the Earth to be an oblate spheroid of 24,901 miles circumference, there must exist a curvature drop of 666,666.67 feet, which amounts to over 126 miles of drop. If we aligned our view of the globe such that one end was at even height with the other, and assumed an even parabolic curve comporting with the precise mathematical globe measurements, we're left with a hump at least 63 miles high in the centre that we're expected to believe steady, flat, wide, lazy water has to flow up and over. Meanwhile, back in reality, on the stationary planar Earth, we measure no more than 6 feet of elevation drop. Spinning spaceballers will claim satellites prove the Earth is a globe. I say satellites do the complete opposite. It's impossible for one thing in freefall to perpetually orbit another thing moving at linear speed, such as the globe Earth must move in its orbit around the sun, as it rotates on its axis almost 25,000 miles every 24 hours, to orbit almost 1 degree around the sun. It is drifted and spiraled across 1,600,000 miles. On the stationary planar Earth, however, we can send satellites high above the atmospheric influences, and they're perfectly capable of remaining geostationary for decades without the need for any fancy acrobatics and impossible adaptations in speed and direction, all held together by a magical pulling force from thousands of miles away. Again, I stress, people who believe such absurdities simply don't even know or understand their own model. Tides are impossible on the spinning spaceball. We get a very regular and predictable 2 high and 2 low tides on the stationary planar Earth, occurring around 50 minutes later every day, although there are local variations in different regions and latitudes. The spinning spaceball says gravity from the moon creates a tidal bulge which the fantasy ball rotates through, but magic must explain the bulge on the backside of the planet somehow. Allegedly, gravity is supposed to be proportional to mass and some inverse square law due to distance. So surely Earth's own gravity would have 1,000-fold greater pull on its own oceans than the moon. Therefore, the rear side facing away from the moon should have all Earth's gravity plus a little of the moon's, combining to create such a massive low tide, the oceans would run dry, with the resultant spin back to face the moon causing huge destructive tsunamis, especially on a solar eclipse, combining the sun's gravity as well. Meanwhile, back in reality on the stationary planar Earth, because the sun and moon move around above us, keeping time like the hour hands of a 24-hour clock, with the sun keeping a precise 24-hour time and the moon being delayed by an additional 50 minutes each day, driving the major high tide ahead of its daily journey, repelling the electrolyte-rich saltwater oceans away in all directions with a diamagnetic repel force, which effectively creates the lowest of the two low tides as it passes overhead. Meanwhile, the second lesser height tide has been driven away behind it, while to the far north and south, delayed effects generally cause just one major high and low per day. Local conditions, topography, and fluid dynamics does all the rest, as water constantly seeks its level. Speaking of time, that's another real globe killer. We measure a day on the calendar from midnight to midnight, but since daytime is when we face the sun, the true measure of time is 12 midday to 12 midday. On the stationary planar Earth, with our sun keeping time like the hour hand of a 24-hour clock, just as we witness it constantly moving in a 15-degree hour drift, thanks Bob, across the sky, over 24 hours, that adds up to precisely 360 degrees, a full circle, to return overhead again in our local time zone at 12 midday, day after day, all year round. But the spinning space ball is moving two motions, once on its axis to create day and night, but shifts a degree a day to orbit the giver of light, the sun. This adds up to 361 degrees, so without adjusting every single timepiece by 4 minutes every single day, 12 midday will be occurring at 12 midnight. The spinning spaceballers will try to bamboozle themselves with this notion of a sidereal day, as though we measure a day by the stars rather than the sun. But the fact remains, a fixed amount of time is a fixed amount of time, no matter how you phrase it. And anyone with a sound mind, capable of logical deduction and engineering capabilities, must see the fault in the globe model. On the stationary planar Earth, as we observe in time-lapse star trails, the stars also rotate around Polaris at the centre of the sky clock, moving 4 minutes per day faster than the sun. So sidereal time is star time, and as such, every 12th of the year, the sun appears to rise in a different house of the zodiac, or zodiac, as we've personified the various constant constellations. And after 12 months, they're back to pole position again, and we start counting another year. For the constellations to remain constant as they do, without ever seeing any parallax drift ever throughout the year, the spinning spaceballers would have to believe that every single star, often hundreds or thousands of light years apart from one another, must be moving at very specific and precise speed and angle and direction, all in order to keep up exact appearances for insignificant little blue speck Earth going around an insignificant minor star in an insignificant arm of a galaxy among millions and billions. And that, ladies and gentlemen, would be a miracle of such incredible magnitude that it would be far more sane to accept that God did it.
Thank you very much for that opening. And folks, I've got to tell you, we've got so many things we're very excited about, including we're going to have open dialogue. Following open dialogue, we'll have the Q&A. So if you have any questions, put them into the old live chat. You can tag me with @ModernDayDebate. Otherwise, by the way, they have to be in the form of a question for the Q&A. If you use the super chat, we push your question to the top of the list, and it doesn't have to be in the form of a question. It can just be a straight-up objection, whatever you want. And with that, we're going to jump into it. Gentlemen, the floor is all yours.
All right. I appreciate that intro, Iron Horse. Would you be open to reviewing a couple thought experiments that I had prepared for this?
Absolutely. That's the whole point of it.
Awesome. Yeah. Let me share my screen. Okay. You see me?
Should be ready. It's loading. There we go.
All right. So first, I want to talk about a ball that's just sitting on a table. Probably the most simple possible physics problem you could imagine. That is not moving, it's just sitting there stationary. First question, are you familiar with Newton's three laws of motion, Iron Horse?
Absolutely. No object at rest remains at rest. Object in motion remains in motion unless acted upon by another force.
There's a couple more.
Well, of course, yeah. That's the basics of it.
Well, no, the other two are different. So then you got F equals ma, and then every action has a reaction, right? But you did get the first one. Points for that. So now, using these laws of motion, have you ever made a free body diagram before, or do you know what that is, Iron Horse? A free body diagram?
Yes, and I know that's exactly how it debunks the globe, absolutely, because there's no way the moon could be orbiting the Earth as the Earth orbits the sun, because the moon is only in freefall motion. And so the free body problem actually absolutely destroys the heliocentric belief. Just like that. I had all these images prepared I was going to show, but, I didn't get around to
No, I think, did you hear me? I said free body diagram.
Free body. I thought it said three body.
No, it's a free body diagram. It's a common thing to use in mechanical problems. You ever seen that before or heard of it?
No.
No. Okay, so for this very simple physics problem of a ball just sitting on a table, a free body diagram is going to look like what you see on the side of the screen here. It is just trying to simplify it to its most basic components, because can you guess how many forces are acting on this ball as it is just sitting stationary, Iron Horse? How many forces?
Zero. Well,
Incorrect.
actually one. There's a force of resistance from the table and a force of resistance from the floor holding the table, but otherwise the only force is resistance.
Okay, so you're saying there's only one force acting on the ball, right?
Correct.
Okay. If that was true, Iron Horse, if one force acts on a body, what that causes is the body to move in the direction of that force. So that cannot be true, because the body is not moving at all. It is staying stationary, right?
That's correct. That's why the only force is resistance at this point. If you added another force, then there's going to be other vectors.
No. If there was only the force the table is pushing on the ball is upwards, right? The table is pushing up on the ball, and if that was the only force involved, that means the ball would go upwards. Is the ball going upwards?
Well,
No.
I disagree with you there. I say that the only thing that's stopping the ball from falling further is the table. It's always the force of resistance. So if the table wasn't there, it would fall to the next place of resistance, which is the floor.
But you're exactly right. The table is preventing the ball from going down, and the reason the ball is going down is because
The ball's not going down; it's at rest.
right. But the table is preventing it from going down. If the table wasn't there, it would have gone down, and that it would have gone down because of the force of
lack of resistance from the medium of air.
That's not a force.
Solid or something of density to give resistance.
So let's break it down the way I would approach it in a normal physics problem. So in reality, there are two forces acting on this ball. There is a downward force and an upward force. I don't know if you can see the text on the screen on the top. There's an upward force and a downward force. And since it is not moving, those two forces equal each other. They're the same. That's so it's not moving. So the force from the table is called the normal force pushing up, and the downward force, we're going to call it weight. Okay? And as we know from Newton's first law, or second law, F equals ma. So we know that weight equals mass times an acceleration. Do you want to guess what that acceleration is called, Iron Force? Iron Force?
Well, the problem, Iron Force, the problem with that equation is that there is no acceleration. So acceleration is zero, and anything multiplied by zero equals zero. So you've got no force at all. The only force, again, is resistance from the density of the table.
You are absolutely right if you are referring to the summation of forces is equal to zero. The sum of all the forces in this problem is zero. That is why there is zero motion. But there is still an upward force of the table pushing up against that ball. You know that's there, right? And that is the equal and opposite reactionary force to the downward force the ball is pushing downward onto the table. Those are Newton's basic laws. Wouldn't you agree?
No, I completely disagree 100%, because the force of resistance is the root word of the word rest. That's why it's at rest. And the body at rest remains at rest. There's no forces involved whatsoever except the resistance force, allowing it to remain at rest. If there was no resistant force, it would drop perpetually. But the resistance force that comes from density, from everything that's already fixed here at the bottom of the universe that we call the stationary plane or Earth, is already there. So it resists it. Without it, the thing in space would fall forever.
So you're saying there's only one force acting here?
Yeah, there's an up and down force, but that's all relative density. You have to have a medium to give buoyancy. And so something like a helium balloon, for example, in the medium of air will find buoyancy, which will give it an upward force. But it's not really a force as such. It's just relative density, never finding equilibrium.
Well, really, we're not even talking about the cause of the force right now. We're just talking about if there is a force at all. And if there is one force, which is the upward force of the table, that you admit exists, if there was no other force, that would... No, you said the upward force of the table. You're calling it the resistance force. You say it exists.
That's right. It's not an upward force. It's just a force that's preventing it from dropping any further. I wouldn't call it an upwards force. If it was an upwards force, it would be pushing the ball upwards, but it's not. It's at rest.
Yes, it's at rest because it's pushing it. It's holding it. It's
not
supporting it.
holding it.
Right? When you hold up
Resisting.
it's holding it, supporting it. When you hold up a very heavy weight, you are exerting a lot of force to hold it still, even though it is not moving, right? There's still a lot of force there, right, Iron Horse?
Well, of course, you have to use muscular force to resist it if that's all you're depending on. But the table is
Right.
a pretty solid object in its own right. It doesn't require muscles and strength and everything to do. It's its own.
Yes, I'm not talking about
strength.
Yeah, obviously the table doesn't have muscles. I'm using the basic physics terminology of force. If something is pushing against something else, there's always a force there. And there's always an equal and opposite force according to Newton, right?
Okay, if you insist. Like, this is getting a bit tedious here.
Well, it's Newton, not me. I didn't make it up. So that weight is always F equals ma, and it's going to be mass times an acceleration. I think you know what that acceleration is called. But if we replace that table with a bucket of water and have it have a buoyant object floating in the water, do you know the equation for buoyancy, Iron Horse? I know you're a fan of it.
I don't really believe in the equations. I just believe something that will displace its own weight sufficiently, and if it's not completely displace its own weight, it will remain buoyant. And if it's more dense than the water, it will sink. I don't really need to know formulas to know why things do what they do, and I think you can bog yourself down in these details forever, which goes nowhere. If it's more dense than water, it will sink. If it's less dense than water, it will float or rise to the surface. Simple as that.
I would very much encourage you to look more into the equations on Horse. I think it helps a lot clarify a lot of how these systems work. So the equation of buoyancy is rho VA, which is density times volume times acceleration. And that acceleration, rho V is always mass, and F equals ma, so mass times an A, acceleration, that A is always gravity, right? It's always gravity. It's nothing else.
But we've just decided that when it's something is at rest, there is no acceleration, which means that the gravity is zero. It's neutral buoyancy, and anything multiplied by zero is zero. So your formula, it just doesn't work. It sucks. You're assuming a pulling force that isn't there because it's at rest. Zero acceleration equals zero.
So I appreciate you sharing my screen on that one. So I think this is something that you would benefit massively from going to a very introductory physics course on, Iron Horse.
I've done plenty of physics, thank you. I don't need to go back to school to know what's what.
Wait 1 second. Well, Iron Horse, why is your screen pink and purple? Is this like a Valentine's Day promote? What's going on?
I don't know. I think something must have happened when he was sharing his screen. I saw it go.
But it's only
It's
your
my
screen.
fault. Why are you blaming me? Jesus.
But it's only your screen. I mean, if you want it that way,
I thought
there's
it was
no
from
judgment.
your
It's a
end.
Valentine's. We're very close to Valentine's. It works for me. Go ahead, Will.
It kind of looks like a glitchy kind of color, like a plasma-y.
I prefer to think of it that Iron Horse is a huge fan of Valentine's Day.
Big Valentine's vibes coming up.
We can still kind of see you. It's got a pink, purple
Yeah.
Valentine's Day filter.
Well, good thing we're mostly talking, not showing things. You still hear me, Iron Horse?
I can still hear. Yeah, I'm just marking around the camera.
Okay.
Maybe switch the camera and coming back again. But
We prefer, though, purple, or I should say Valentine's Day, rather than no video feed. No one's going to make fun of you.
Look nice.
I feel pretty. Right.
Very much are. So I guess the point I was trying to get across is when you break down these equations on how things work, including buoyancy, which is the thing you preach about all the time, about how the entire universe works, when you actually break it down into the math, the gravitational constant is unavoidable. That's an inherent part of those things on the most basic fundamental level.
Well, I think that's a bit of a stretch to say I preach about it all the time. Well, I don't. I think that there's only one physical plane in the entire universe, and that we live on it, and it's fixed at the base of the universe. I think all those lights in the sky are anything but terra firma, so the laws of physics don't even apply to them. That's why you brought up the one about the star trails, for example. That's why they behave in the manner in which they behave, because that's completely different from the laws of physics at which we operate here, fixed at the base of the universe in the physical realm, the only physical realm, potentially infinite. But as far as we know, to the best of our abilities, we're sort of landlocked in by the Antarctic ice wall. But there is the potential that we feel that more land exists out beyond there, and that's where, of course, extraterritorial and extraterrestrial people would come from. And I almost think that we're actually imprisoned in here for a reason, probably because we're warlike, we're full of diseases and parasites and whatnot, and that we're basically isolated from the rest of the universe, or the physical realm at the base of the universe. But the star trails themselves, they don't prove the shape of the Earth. Like, you can easily look at something rotating around above you, turn around and face the other way, and it will appear to go the opposite direction. There is actually a more detailed explanation for why they appear to go around a southern celestial pole star, but I don't feel a debate is the best place to try and describe something that would take, a good half an hour lesson on. It is possible, though, and it doesn't prove anything about the shape of the Earth. I think that water level and the behaviour of water, how it behaves, we can make a model, for example, in a big dish of water and place a bunch of rocks into it. And it doesn't matter how big we make our model, it will still represent basically the model of the stationary planar Earth, or flat Earth as people call it, as long as the land masses or the rocks are above the water level. You can pour any amount of water onto it and the water will still seek and find its level. You can have flowing rivers and lakes, all that sort of thing. You cannot do that with a globe. And no matter how big or small we make our model, we'll still have one atmosphere of air pressure above it, pushing down on it. Whereas to try and represent a globe inside of a vacuum with a pressurized atmosphere and water clinging to every surface at multiple different depths, it's just absolutely impossible to do. So we can easily model our version of reality. Yours is just a fantasy with full of assumptions and theories. There's nothing realistic about it.
Iron Horse, this is another kind of fundamental question. Why does water pressure get heavier as you go down in water?
Because everything of mass obviously has density. And so the more of it, the more amount of it is above you, which is, there's just a universal up and down. So if you're deeper down, there's more of it above you, so you're going to have a higher pressure. It's the same with the atmosphere. There's a fixed amount. But, from the bottom of the ocean to the top, when you reach zero, there's a pressure gradient.
And all that water is the same density, though, right? It's all the same density. You can't compress water to be denser, but you can make it higher pressure. So why would it get higher pressure downwards? Sorry?
You can make it denser by making it cooler, but you can make it denser by lowering the temperature down to about 4 degrees Celsius, but that's besides the point. The point is, yes, it is basically the same density all the way, but it's all about volume. So I simplify the formula for weight, is that the weight of the mass equals the volume of the mass times the density of the mass. So everything has a molecular density, and the amount of it determines how much it weighs. So if you've got 1 litre of water, say you're under 1 metre surface of water, well, there's X amount of cubic metres of water above you. But if you go down 10 metres, well, there's a lot more. So the amount of volume will put a lot more weight on you, and that weight is what we call pressure.
But why does the direction downward mean anything in your model? Because that's just how reality works. Reality requires a base. The Earth is the base of the universe. You can't. Why does it require a base?
You can't build a building without a base. Everything requires a base, or it will fall. You need a force of resistance to prevent it from dropping.
Why does it require a base in your standpoint, fundamentally speaking? Like, what if it didn't have a base? What would it look like? If it didn't have a base, what would happen?
It would just keep dropping, keep falling until it reached some limit at the base of the universe, which is where we live. That's where everything physical already is. It's already there, so that's why we have a base. It exists.
But
that's how we have a physical reality.
But it seems maybe it seems a little arbitrary to just go in one direction. Maybe it could have gone in a different direction, or it could have gone outward, like a radial direction, or any other direction.
But it did.
Yeah,
that's why,
right. That's why it's arbitrary.
Think of music, for example. When we talk about the scale of music, what do we call high notes? We call them high because they go up, and we call base notes down because they're more base. That's why they're basic. So the more base something is, basically you could even describe our whole physical realm as sound. It's just very, very, very slow sound, and that's what makes it the base, very, very base. And then as you go higher and higher and higher, things get lighter and lighter. Oh, where are the lights? Oh, they're up high in the sky. Our entire universe can be described in terms of frequency, vibration, energy, vibration, and frequency. And music is an example of that. Everything is on a scale, and the base is always at the bottom. That's where we are, on the base. It's just the way it is. You could say, why didn't it go sideways? Why didn't it go upwards? It just didn't, because this is how it is.
So I guess the problem with that theory is that that's just how it is less of an explanation than I have. Right? I have more reason to believe that is the specific direction things will be going towards, right? I have more reason.
You invent special forces, imaginary forces, the forces that have never been seen. You assume that things on the opposite side of the planet from where you are right now are being pulled up towards your feet because of this center of gravity of mass. It's all imaginary things that have never been seen, whereas all observations of density and buoyancy are things we can actually test and observe and see for ourselves. They're not something in this fictional, over there, out of sight, out of mind place, beyond the horizon. These are real physics, stuff we can actually test. All your stuff is theoretical, and theories are fine, but once they've been tested and pushed to their limits, now we know they just hold no water. In fact, there was one thing I wanted to tell you about gravity. Saved this quick meme about where Newton made up gravity. They said, here's how it went down. Newton made up gravity. Later, they realized the calculations all lead to a giant singularity where all of the universe gets squished into oblivion. To counter that, they made up dark energy, which is basically anti-gravity. But then calculations now showed everything will move away from each other until dark energy rips the very fabric of outer space. So to balance both, they made up dark matter to hold gravitons and dark energies together. It is one imaginary justification after another. One big imaginary psyop. Whereas here on the stationary planet Earth with relative density, we don't need to make up anything.
I mean, you're just describing the never-ending exploration of science and discovering new things and how old ideas can be wrong and new ideas can come along. It doesn't mean that all of science is fraudulent. And if you were going to believe that, then I think you would be in the category of a hyper-skeptic.
I'm not saying that all of science is fraudulent. I'm just saying that a lot of it, especially when it comes to the whole spinning space ball idea, is completely made up theoretical nonsense to back one idea after another. So if you go back to the reason why they wanted to make it a spinning space ball in the first place, why that Pope John Paul III encouraged Copernicus to go up with it, it's because they knew there's a loophole in the legal system where anything found lost at sea belongs to they who finds it. So when they put the Earth lost in the galactic sea, the galaxy, that means the Vatican, who discovered it, can lay claim to ownership of all land, wealth, property, and livestock, and the citizens of the ship are the livestock of the ship that they found lost at sea. So that's the whole reason behind it in the first place. And people like you defending it are basically just modern-day Stockholm Syndrome sufferers defending a very, very outdated, archaic, barbaric system that is putting the whole world into slavery.
Jeez, you definitely went over a lot of points there. But I kind of want to go back to when you stated that I'm believing in something that can never be observed. It's completely intangible, right? You can't see gravity, right? And I was trying to think of an experiment that if you could have like two really massive objects like sitting really closely to each other, and if they like got closer to each other with no other reason for them to do that, that would be a supporting statement for gravity. Would you agree, Iron Horse?
Probably not, because those things would still be like a trillionth of a trillionth of a trillionth of the mass of the Earth itself beneath it. And so if they were to overcome Earth's gravity to do that, there's probably some other force involved, like electromagnetics or electrostatics or some sort of like attracting like type of force. But I don't think that would be evidence of gravity or the attraction of mass, as I call it, the pulley sucky force of diggity. I just don't think that would prove anything.
So if you could make sure that the gravity of the Earth was counteracted perfectly, like you don't have to worry about the Earth's gravity messing up the experiment, and you can make sure all of those masses are inert electrically, there's no electrical force involved, they could be made of rubber or something, then that would improve the likelihood of it supporting the potential of gravity, right?
Possibly, but I fail to see how you would do this.
No. But if that was possible, it would support gravity, right?
It's a complete and total thought experiment, yes.
Okay.
And would it support gravity, or would it just support the fact that, like attracts like?
Well, no, there's nothing there other than mass, and it would be a mass attracting another mass. So, I know I shared my screen before, but I have one last slide I want to show, and it's only going to be like 10 seconds to show this slide. Could I share my screen one last time? Okay. Good deal. So, I have fantastic news, Iron Horse. Y'all see my screen? Okay, I have fantastic news. I actually looked up that experiment I was describing to you, and not only has it been done, it has been done hundreds and hundreds and hundreds of times and has been filmed dozens of times by people in laboratories that demonstrates the actual working model of gravity in a tangible space with direct proof as close as it can possibly be asked for. So all these videos are demonstrating that exact process that I was talking to you about. It's called the Cavendish experiment, and I'm really excited that we were able to see that together, because now we know there might be some evidence for gravity. Oh wait, did he leave?
I think he is still here.
Okay.
He's certainly digitally still here. Whether or not he's in the same room, he might be under the table or something. There he is.
No, I was under the table. I was listening to that.
Okay, did you see the videos that I just showed you? I was
familiar with the Cavendish experiment.
Okay, did you see the videos I just showed you? It was important. It was showing you that it has happened with many, many different experiments, many different times that have been filmed over the internet. It's not like a one-time deal or anything.
As I'm saying, that the Cavendish experiment relies upon a torsion bar, which is something that hangs from a singular piece of thread, and these things are supposed to be balanced. So technically speaking, if you had it perfectly balanced, the pull from either side of either ball would be equal, so the thing wouldn't move at all. So it shouldn't work. The fact it does work just indicates that there is something imbalanced, and it's actually physically impossible to ever get something perfectly still. So eventually it's just going to swing around and come to rest somewhere, and you're going to claim that as proof. Even though, as I said already, the gravity of the Earth pulling it downwards should be trillions and trillions of times stronger than those little balls in the first place. You haven't isolated gravity. You can't isolate gravity, even if gravity existed. It's not like I'm saying gravity doesn't exist. Gravity exists in its strict meaning as it means weight, and everything has weight. But it doesn't mean a pulley-sucky force to biggity, especially not of balls that are a fraction of the size of the massive planet you guys believe we live on.
So, but you do understand the Cavendish experiment is the two balls hanging on the thread, but then you put additional weights next to the balls that are not hanging on the thread, that then those two other balls twist and get attracted to, right?
Well, they come to rest against it. It doesn't mean they've necessarily been attracted to it. Like I said, if you balance those two big balls exactly in the center of the two little balls, then the pull of both big balls should be equal either side to both of them, so it shouldn't move at all.
You're right.
Near it, it's going to come to rest.
No, you're right. If you
theoretical,
no, this isn't theoretical at all. These are dozens of experiments that have been done in even high schools all across the planet. But you're right. If you put them in the middle, it'll cancel out and it won't work. And that's why they don't do it that way. They make sure those big heavy masses are very close to each one, but not so close to its resting position, so that it has movement. It will move from its resting position to a different position only as a result of the positioning of the new masses in the new positions. That is the only difference that causes these at-rest masses to move. There's no other change in the system, and this has been done thousands of times over hundreds of years.
Yeah, and that's where I say you're just absolutely wrong. There's all sorts of other forces reacting. Like air itself isn't perfectly still. There's going to be air molecules constantly circulating around things, especially if they're a ball-shaped thing, and that's going to build up an electrostatic charge. And an electrostatic charge, now we used to do it in high school, just in school, by rubbing a plastic ruler on our shirts and getting little bits of paper and holding it above the paper, and it would pull it up. Anti-gravity. That's all you're really doing. You're actually proving anti-gravity, not gravity.
No, you're absolutely right, Einhorst. That they're even just moving around the room can disrupt the experiment, and that's why those high school experiments, they absolutely do hold a lot of weight, and they do it thousands of times. But there are more adult versions of the same exact experiments that are done in a vacuum, right? They make sure there is no wind and is no electrostatic potential for there to be disrupting and violate the experimental results, and that's been done hundreds of times too.
You do know, of course, that there is no such thing as a vacuum. It's not even close to a true vacuum. Like the strongest vacuum that what's his name Action Labs has, he got donated this big, massive perspex thing, huge walls. Somebody did the data on it and checked it out, and it turns out that the strongest vacuum that we can artificially make is equivalent to what actually exists to the normal flying height of a plane at about 35,000 feet. So, if a window got blown out, everything gets sucked out of it. That's the force of the strongest vacuum we can actually artificially create here on Earth. So if you're trying to tell me that they actually did it in a vacuum, you're not quite correct. There's still going to be gaseous molecules in there of some amount.
I appreciate that correction. But they also make sure they not only put it in a vacuum, they also wait for potentially hours to let all of any potential gas in the system to settle and let the masses at rest, make sure they are not waving in any which way. They are completely at rest in its unique position. They wait hours for it to wait in its resting position, so that when they introduce the new weight in its new location, there is no potential for any other influencing factor to cause it to shift in rotation other than the introduction of the mass. So there is no other issue that you can point to try to...
How do you introduce another mass inside of an already vacuum system?
That's a great question. You actually don't put the mass in the vacuum. You put it outside of the vacuum, near the mass that is in the vacuum. So it's outside of it because gravity works through the wall of the vacuum.
Okay, so did you show a video of that for us?
I did. I would love to show it again if you'd like.
Inside the vacuum?
Yeah, it has a glass image that you can see the masses inside of it.
Yeah, no, I did miss that one.
Yeah, they actually manufacture these experiments because they know universities and colleges like to use it very often to demonstrate how gravity works and how you can directly observe it tangibly. This isn't a arbitrary idea that no one can see. It is something that you can not only observe its effects of, you can directly measure it in a classroom, in a laboratory. So does that give any support to the potential of gravity's existence?
No, because once again, the downward force should still be billions and trillions of times stronger. That should prevent that from happening in the first place. So there's obviously other forces at work. I've even seen somebody say something about the types of wires they use even generate some sort of electrostatic force as well. Generally it's with lead. But anyway, I think we can move on from that because it's
let's move on from that. I would love to hear your explanation for the stars. Did you see that little video I showed about how the stars do retrograde motion from our perspective?
Retrograde motion.
Yeah. Did you see that video?
You're talking about the planets, weren't you?
Yes.
Is that about the planets?
Yes.
Well, they're not stars, even though the Greeks called them planetae, which means wandering stars. So technically, that would make Earth a wandering star as well, which I believe it goes dark at night, so it wouldn't actually be a wandering star whatsoever. But anyway, yes, and that's exactly how it works on the stationary planar Earth. Actually, if you look at the actual motions from the geocentric point of view, each and every one of them makes like a gyroscopic type of spiroscopic type of pattern, which creates sacred geometric patterns which work perfectly symmetrically. If we were hurtling through the vacuum of space, as I say, 10 times faster than the electromagnetic railgun projectile every night, all all of these things would be absolutely impossible, because all of these things are moving such absurd speeds and distances with us at the same time, that how could they make such perfect sacred geometric patterns unless it was they in motion above us, while we sit here stationary and witness it and track it. I've got plenty of images of all that sort of thing as well. It works beautifully on the stationary planar Earth without any extra assumptions whatsoever, no extra motions. And that 10 times faster than an electromagnetic railgun projectile speed is just our second slowest speed. If you can imagine that. That is phenomenal.
So why does that happen on a flat Earth?
Why? Because that's what they do.
But why do they do
it?
it?
Have to accept for what we observe them to be. Why do they do it? Because that's what they want to do. All the stars move as a single body around Polaris, but these wandering stars are greater bodies of some sort or another. And I think, in a sense, they might even be something like a small version of the moon, but they're just locked in a sort of a toroidal field that everything rotates around, as we've proven with the 15 degree per hour drift of the sun. Everything creates an electromagnetic field, and these particular bodies act in accordance with the energies that they've sort of got trapped into, and that's their orbital range.
Let me ask you this. If you never saw those planets moving like that, would there be any reason you would predict you could potentially see something like that moving in the sky for any reason?
Well,
because the globe Earth can and does.
But when it's been tracked for thousands of years, and people have been recording these patterns for that long, and in fact, I think back in the day, people actually lived for thousands of years and probably grew to greater proportions as well. They were able to track these things, and they knew about it. Like the Antikythera device, for example, is a very accurate measuring tool that could measure backwards and forwards for thousands of years for observations, especially including the moon and lunar eclipses, and they could even tell which shade of red the moon would go. Whereas modern astronomy can't tell us any of that sort of stuff whatsoever. They can come pretty close to making a prediction of when the eclipse will be, but that's because it always occurs on recurring patterns, the Soros cycle.
But why would an eclipse happen, though, on a flat Earth?
Okay.
Why?
Okay. Depending which of these particular bodies that are always going close to the sun, just like when the moon is so close to the sun, we call it a new moon phase, it's completely invisible to us. Well, there are permanently at least 3 or 4, maybe more, similar bodies like the moon always hanging around the sun. And every now and then, one of them will come between the sun and the moon, and depending which one will determine which shade of red the moon turns during an eclipse. So it's basically something nearer to the sun that is normally invisible to us, but we have actually got images of it from high altitude photography, which is the thing that made most flat earthers today, because we've been able to send cameras up above the atmosphere and see things that we've never seen before. You can see 3 to 4 different orbs right next to the sun, and every now and then one of them passes between the sun and the moon, eclipsing it. That's what does it. Nothing goes beneath the Earth. It's definitely not Earth's shadow. And in fact, I've hung a sphere, it's a floating buoy, a fisherman's buoy type of thing, it's a good sized sphere, out on the clothesline outside, used a flat board, square board, and just made shadows on it at different heights and different lengths with a flat, straight board, and every single one of those shadows looks exactly like a lunar eclipse shadow. It curved because of the surface it's falling upon, not from the object that causes it, even though I still do think they're orbs that do create the lunar eclipse shadow. They're just so close to the sun.
So why do you think it's red?
Basically because of the spectrums of light. Like going into the nature of light is a huge topic, and I think it's a huge flat Earth topic. Is basically when sunlight hits, solar radiant energy hits our atmosphere, that's what causes the fluorescence of our atmospheric gases that gives us daylight. But the first and last one of these to glow is neon, and neon at the peripherals glows that orangey red colour. So when all the solar energy is blocked from the Earth, it's hitting during the lunar eclipse, it's hitting the moon. It's just basically the Earth glow that's going to be reaching the moon, and it's given it that red colour.
But the Earth doesn't glow red.
No, but actually, that's one I have to think about.
Okay, that's fair. And what was I? Oh yeah. So let me know if I understand.
I got it.
Oh,
I got it. I got it. Is that when the moonlight is basically projecting solar radiant energy into our atmosphere, and it creates its own light in the atmosphere, which creates the holographic plasma projection of the moon. And so when the sunlight stops hitting the moon, the amount of light that it can project into our atmosphere is not sufficient to create the bright glowing moon that we're used to seeing. Like the moon we see isn't actually the moon, it's the holographic plasma projection. So the tiny amount of light that hits our atmosphere is only sufficient to light the very the neon, which requires the least amount of solar radiant energy to glow, which always glows red at the peripherals. And so because it's such a tiny amount of solar radiant energy reaching us, that's a dark red. That's the answer.
gotcha. So in reality, it's not red over there. It's just red from our perspective because it's going through the atmosphere.
Pretty much, yeah. Like you have to understand what the moon itself is if you really want to know. Like the moon is a tiny little orb up really high, almost as high as the sun, and it floats beneath the massive inverted ocean of superfluid helium held in place by the frozen hydrogen firmament. And so it reflects solar radiant energy down through the firmament B, the gaseous layer, only about 12 to 14 miles high, in direct line of sight to each viewer. And that's where it creates the holographic plasma projection that we see and think of as the moon. It's actually fluorescing atmospheric gases creating its own light effectively, but only the parts that are lit by the sun. So it's both lit by the sun, so you see shadows of craters, but it's also creating its own light. So it's two different things.
But the moon is illuminated by the sun. Wait, sorry, did you say Yeah, so the moon doesn't create its own light, right? Only the sun?
They both create their own light, but
okay.
The light that we see through our atmosphere is like looking through a veil. So like say if you had a really long tunnel in front of you and you put down a sheet in front that you could just see through,
right? And
you ran a string of, say,
like a filter
LED lights all the way through it, a massive coil of it, then each time it hits the screen, that's when you see the effect of the light, but you're not seeing the actual light itself, you're just seeing the effects of it.
You're like colored glasses, like rose-colored glasses or something.
In a sense, yeah.
So I have a question. Do you think that my description of a lunar eclipse would make sense if we were in a globe?
No, not at all, because we've got the Selenelian eclipse, and that's the one where as the moon is setting, the sun becomes visible, but the shadow we see is coming from the top down. It's going in the wrong direction altogether. And it shouldn't even happen in the first place. You shouldn't see it eclipsed at all, but everything is completely arse backwards when it comes to the way the shadow of the lunar eclipse occurs. It shouldn't happen.
Okay, so what if it's...
I watched blew my mind.
What if it's not a Selenian eclipse? What if it's a normal eclipse? Would that make sense from the globe perspective?
I would have thought so, because I used to be a huge glober myself, and the first time I went out to watch a total lunar eclipse, I thought this is going to be incredible. I'm really looking forward to this. And when it came about, it's only about 9:30 in the evening, so it's a couple of hours after dark. I had the perfect lookout for it. I knew my model inside and out, and when the shadow came from the top left diagonal, it just felt so wrong. Everything about it was wrong. I've seen other total lunar eclipses where the shadow came from the bottom right across diagonally, almost at the same time of night. None of them actually make sense on the heliocentric model. You would think if it's a perfect alignment between the sun, Earth, and the moon, that when the Earth shadow comes up in between it, it should sort of make sense to either come from the bottom up or from the top down, but not these weird angles that make no sense whatsoever. I mean,
the angle at which it comes from is very much dependent on your location on the Earth and your perspective of the moon at the time. So depending on where you're on the Earth, it's going to look like it comes from a different angle. And you being in Australia, maybe you're expecting a different direction it was coming from compared to America or something in the North Hemisphere. But I definitely wouldn't say all of the Earth is flat because it didn't come in the direction you were expecting. That might be a little bit jump at the gun there. Right?
Yeah, well, see, I don't think it's the Earth casting a shadow whatsoever. I'm 100% certain that it's some other celestial orb that hangs around the sun and that nothing goes beneath the physical plane at the base of the universe. All high-altitude balloon footage shows the sun is always up there. You can see the tiny moon is like a tiny speck in comparison to the size of the sun once you're above the atmospheric influences. Nothing that our modern era has shown us, thanks to the digital camera and high altitude balloon footage, matches all these ancient superstitious beliefs, which we can now sweep away. They no longer exist because we have modern technology, and when science has to move forwards, keep going forwards, and has to accept the new evidence and run with it.
And when I was talking about the Coriolis effect, did you hear what I was saying?
Yes.
And how that is supposed to work, and how it would be very different on a flat Earth if the flat Earth had a moving atmosphere?
Absolutely. I mean, my screen's a bit pink still by the look of it, unfortunately, but you can see how I've got the map there, right? That's
Yes.
our standard sort of map. So there's 3 circles on it that we basically pay attention to. The middle one's the equator. We've got the Tropic of Cancer in the center, Tropic of Capricorn on the outside. So the sun drifts from one tropic to the other, and when it goes around the equator throughout the seasons, that's our 2 equinoxes. Cyclone and hurricane seasons are generally in the summer season, so the sun's on that side of the equator. And just like when a boat passes through water, it will create vortices in its wake, and they'll both spiral off in opposite directions. So when the sun's in a particular side of the equator, those vortices are going to spiral off in that side. The ones on the other side are going to go out from this side. The ones on this side heading out, say, to the winter side, they're not going to be creating enough of a low pressure effect and heat to create a tropical storm. But the one that's really warm, where all the warm water is, and it creates a low pressure, and then fluid dynamics take effect, it will create a cyclone happening in the opposite direction that generally won't happen until the summer season on the other side, where it will go the other direction. So it makes perfect sense on our model, more so than on yours, because, I mean, curving water and a pressurized atmosphere in a vacuum in themselves debunk themselves. At least with ours fixed at the base of the universe, the effects of the sun creating heat on opposite sides of the equator makes a lot more sense to me.
Well, you keep on saying a pressurized ball with an atmosphere in a vacuum. What is wrong with that idea? How could that be false in a globe model?
Absolutely, everything about it is completely false, because everything with pressure always seeks to equalize, whether it be high to low or low to high, will always try to equalize. And when you add up the amount of ridiculous speeds that your spinning spaceball has to be going, it's not just spinning on its axis once per day, which is only 1 1/3 times the speed of sound. We're talking about a speed of about 86.8 times the speed of sound in its orbital motion. So anything that moves through air pushes away the air. Everything of the Earth that moves through air and has air resistance. The entire Earth is of the Earth, so it should be moving through the air, not just magically pulling it all along gently with it, with clouds floating around, hot air balloons gently wafting.
So
all
atmosphere
is moving phenomenal speeds.
Atmosphere is made of atoms, which have mass. You would agree, right?
Gaseous molecules. Yeah.
Okay. And in the globe model with gravity, that mass would be attracted to a massive object like the Earth. You would agree?
But it's not. That's the whole thing. The air molecules are free to float however high and long they want to, and then they've got no reason to come back down where gravity gets weaker and weaker. They would just all fly off in a nanosecond.
But it's made of mass, and it would be attracted to a massive object like the Earth, right? How is that inconsistent?
Well, but you say the oceans themselves are attracted to the mass of the moon. The moon's 250,000 miles away. So
don't run away from what I said. Let's talk about atmosphere.
I'm saying, I'm getting there. If it's strong enough to attract trillions and trillions of tons of ocean water, which is far more dense than the atmosphere, then what the heck is stopping it from pulling all our atmospheric gases away as well?
What the moon's pulling the atmosphere away?
Yeah, what's to stop it?
It's because it's the same reason why the water doesn't fly off the Earth, because the Earth is much, much more massive than the moon. So the atmosphere will not go towards the moon if the Earth is more massive than it, right?
The oceans weigh trillions and trillions of tons, and the moon is capable of pulling them around, according to your theory.
Yes, but they don't leave the Earth.
No, but so the void of of space itself would
Vacuum.
be sufficient for the less dense molecules of air, which have no reason to stick to the surface in the first place. They would just keep on going, leave us off like a comet's tail. And then without any air pressure, our water would do the same because it relies on air pressure to remain a liquid. You put water in a vacuum, it instantly boils, vaporizes, and disappears. So in a nanosecond, our Earth would be as barefaced as the moon itself.
So you were saying
the base of the universe, everything finding its place, it works.
You're saying the less dense molecules of air would fly away from the Earth, but those less dense molecules of air are made of mass and would be attracted to another massive object, right?
But they're of insufficient mass. Mass is proportional to its mass and to its distance. And the further away it gets, like each individual molecule has virtually zero mass for all intents and purposes. Like it's not all stuck in a thick blanket to the surface of the Earth because of its lack of mass. If it was, okay, we'd all be crawling around on the ground.
But it does have mass. It's not zero mass. It has mass, and that's the entire foundation of gravity is mass. So if you say these things shouldn't act like as if they have mass, but they do have mass, so of course a mass would be attracted to another piece of mass. Just because it's gas doesn't mean it stops following the rule of gravity.
You do understand the properties of matter, though, don't you? That a gas will fill its container and bounce off all the walls.
So
but
that is what we. So that level of education of how gas works is usually what is taught to elementary and high school children, because it's very simple and works in most cases on ordinary observations. But that is definitely not true when you enter higher level physics courses in college and in beyond, because that is a rule of thumb, if you will. It is true sometimes. It is not true universally.
So in other words, the more indoctrination you get, the more inclined you are to believe something. It's like a priest moving up through the levels of priesthood. And it's all faith-based, isn't it? There's no evidence-based whatsoever.
So
children will understand simple lies quite easily. So
it's kind of like quantum mechanics, or even atoms. Even atoms, right? Atoms is a good example. We don't educate children how atoms work, and I think you believe in atoms, but whatever is small, even bacteria. We don't educate children on the fundamental aspects of bacteria and medicine and these complicated things, because they are very, very underdeveloped and not ready for these very high-level understandings of how physics works. That is the reason we don't teach children the same things we teach them in college. So physics in high school can be wrong, yes. Physics in college is where you start understanding the nuance and how complex the systems are and how they can act in different situations beyond the normal everyday categories.
Yes, well, I actually prefer to get my knowledge out in nature. And I can tell you that everything you're saying is just theoretical, made up bullshit to try and excuse one thing after another that gets wrong and wrong. It's more like the little old lady who swallowed a fly. She has to swallow a whole web of lies to begin with, then she has to swallow a bird, and she keeps on swallowing all these different absurdities until she ends up choking on a horse. And that's where the globe model is at this stage. It's dead, of course.
Iron Horse, why do you think all of modern technology and modern science is done by globe believers and never by flat earthers? Why do you think that?
Well, because they've all been indoctrinated in the same belief, and they've had no reason to question it. And basically, if they want to keep their reputation, then you go along to get along. You don't try and fall outside of the mainstream model, whereas flat earthers generally are allowed to question things. They don't have a career that depends entirely on keeping up appearances. We have our daytime jobs. And when it comes to questioning the nature of reality itself, we're not restricted to not believing the things we're taught. Like technology exists whether or not you believe in the globe. It will still be the same either way. Nothing changes when it comes to technology.
You're misunderstanding my question. My point is, why do technologies that work and actually produce innovation in industry with functioning new technologies, why are they all produced by globe believers and never by flat earthers? Like technology is unrelated to flat Earth, completely unrelated to globe. Why are they like new medicines or new electronics? Why is it always by globe earthers?
Because it's completely unrelated. Some of them might be Christian, some of them might be Buddhist, some of them might be Muslim.
But they're never flat earthers.
Technology is technology. Everybody's a flat earther, whether they know it or not. That's the whole thing.
But they don't believe in flat Earth.
You can believe whatever you like. You can believe whatever you like. It makes no difference as long as the things you do working practically work.
I just think
to do with the shape of the Earth either way.
I just think if flat Earth was true, and truth is what breeds innovation and functioning products and functioning projects and success, it would breed success, right? It would breed a successful project management system because it's more true. You would find truth easier as a flat earther than you would as a glober. But globers are the ones who are always finding innovation in industries and are successful in business and in technology, always. Never flat earthers, ever. Why is that?
I think that's a highly dubious claim, and you've got no evidence to support it.
Well, please list one successful flat earther.
More and more these days, but it's probably something that they'd rather keep private because they don't want to put up with ridicule from religitards like you fellas who believe we live on a spinning space ball. You are all so deeply indoctrinated that all you've really got is a whole heap of ad hom attacks against the flat earthers. You call us the most stupidest, uneducated people in the world. You think we know nothing, we understand nothing about physics. We get made fun of relentlessly, like we're the only minority group in the world where it's still openly permitted to be openly slanderous and ridiculously nasty towards us. And yet we're at the forefront of modern technology. We've embraced technology. The digital camera has shown us stuff that we've never seen for thousands of years, and we've only had it this century, and we're embracing it. We're moving ahead. We're moving forward. And so what if we're not all inventors, Like, how many people actually are? Most people are just improving on somebody else's invention anyway. It's all just known technology that improved upon. It's got nothing to do with what you believe privately about the shape of the Earth. Nothing whatsoever. It's completely irrelevant.
Yes, but it does have to do with your methodology. It has to do with how you approach a problem. If you're approaching a problem that seeks truth, if you're approaching a problem with a methodology that seeks truth, then you're more likely to find success in certain industries. And I'm not even trying to insult flat earthers here. I'm trying to look at it from an objective standpoint. If there is one group of people who say they're right about everything and 99% of everyone else says, no, they're probably wrong, and then all of industry and innovation comes from those 99%, and none of it comes from the 1%, I think it's pretty clear that that 1% might be mistaken.
Yeah, well, I don't think that you guys are coming up with any new innovations whatsoever. As I said, you're just improving upon something else that somebody else did, who may have, in the first place, even believed that the Earth was flat and stationary, not hurtling through this vacuum of space at billions of miles an hour.
Yes, but Iron Horse, flat earthers don't improve. Yes, but flat earthers do not improve on past technologies like globe earthers do.
That's a blanket claim. That's a blanket claim that you've got no evidence for whatsoever. That's just bias, absolute bias, and that's typical of your life. It's because you think, oh, we're so good, we're so clever, but you can't even prove how we can have a pressurized atmosphere within a vacuum clinging to a ball. You can't prove a single thing about your model. So
again, like, look at it from this perspective, right? Look at it from a 100-foot view. Either all of those people, all of the 99% of scientists who find innovation in technology, and all those people are either misled or liars or confused or dumb. All of them are dumb. Or the 1% of you guys are right. The ones who don't find innovation, don't improve on past technologies. Those people are right. Does that make sense to go with that approach?
Tell me which one of these 99% of the brainwashed mob actually rely upon the Earth being this spinning space ball hurtling through a vacuum of space in order for their innovations to work. Not a single one, which is probably why it's now a good time to leap into satellite technology, because that was one of my main points I brought up. And when I say that something like the ISS going 17,500 miles per hour, how is it orbiting something going 66,600 miles per hour every 90 minutes while it's it's just not possible. It's in free fall motion, but the Earth is going that way. Anytime if the ISS got in front of it, the Earth would smash into it. Every time the ISS got behind it, the Earth would race away from it. None of that is possible. But if you think practically, in practical terms, as we know, where the Earth is stationary, fixed at the base of the universe, where satelloons exist, we can easily have geostationary things. And things like the ISS can be explained by also moving in these spirographic patterns, just like the planets do, by reacting to like a superconductivity device in accordance with the superfluid oxygen layer that we call the ozone layer.
Okay, I appreciate that question. Iron Horse, do you know what an inertial frame of reference is? Do you know what that means?
Yes, I do. And I know that if you jump from something like, say, a moving train, you are not going to continue moving the speed of the train. You're going to slow down immediately and hit the ground hard while the train continues going off. Same if a skydiver jumping off a skydiver plane is not going to continue moving the speed of the plane if he jumps from it. So anything that leaves a frame of reference that's in motion very, very quickly loses that frame of reference and starts dropping straight down.
Okay. So let's think about this whole system as a whole, right? Hypothetically, if the Earth was standing still and not moving, would that satellite orbit make sense to you?
Which satellite orbit are you talking about, though? Like there's heaps of different types of satellites.
What? Any satellite orbit? I don't know what you mean different. There's satellite orbits the sun, Earth.
Nothing orbits around the Earth. Everything orbits above the Earth. The Earth is fixed at the base of the universe, so everything that's orbiting is going around above us. Like
I thought we were entertaining the globe idea for a second, or trying to prove me wrong about the globe, right? So assume the globe for a second, and assume the globe is not moving at all. Would it then make sense for a satellite to potentially orbit around that globe if it wasn't moving? Would that make sense to you then, or no?
Well, no, because if gravity was holding it in place, it would still pull it back down.
So even if the Earth was not moving, the satellites would still not make sense to you?
No.
Okay.
So,
here's the way they...
You can't say even if, because we know for a fact that your model 100% relies upon these fantastic speeds, and if you're not going to include orbital speed at all, then it's no point even hypothesizing about it. It's a ridiculous notion. We have to entertain the model as it is, and you cannot start doing these thought experiments just in case. You know, you can't cover your bases that way. We have to do either.
You have to start.
Space through space, or we're going to talk about the stationary planar Earth fixed at the base of the universe. So you can't start with nonsense that doesn't exist.
You have to start with fundamentals first. You can't jump to quantum mechanics and astrophysics. You need to start with fundamental basic physics. That's why I did a physics 101 problem with you. If it wasn't moving, okay, ignore the moving thing. The first way they started to figure out orbits could work, and Newton figured out orbits could function properly, is he imagined a cannonball being shot very hard, very hard. The harder you shoot a cannon, the farther it travels. Now, pretend you're a glober for a second and assume there's a globe. And if you shot a cannonball hard enough so that the arc of that cannonball would be farther than the radius of the Earth, what do you think would happen?
It'd disappear.
But it would come, well, it could be disappear, or it's supposed to arc down, right? Cannonballs always arc down. So it would still arc down, but the arc would be further than the radius of the Earth. So what would happen is it would arc so hard that it would actually continue arcing indefinitely around the planet. And that would become, instead of... Right? Do you see how that...
Absolute nonsense. Like, it doesn't work. It might work once, but it's not going to keep on doing it perpetually. It might miss once, and then it's going to still disappear as space dust, if indeed we were in space.
So you're actually right. So you're actually right. It would not work indefinitely when it's that close. Like a cannonball is a kind of silly of a relation, but it's just a way to think about it. Because cannonballs are in the atmosphere, and the atmosphere would slow it down, and it would eventually come down crashing into the Earth. But that's only because it's in a thick atmosphere close to the Earth. That's what's slowing it down. When it's far enough away from the Earth's surface, when it's deep in a vacuum of space, that atmosphere is not slowing it down anymore, and it's able to continue that orbit. You know what? That's another lie. It would actually continue slowing down because the atmosphere extends very, very high, but that orbit would happen much, much, much longer, because it'd be less force slowing it down.
You just have to keep hedging your bets. Everything is theoretical. It's all absolute nonsense. Like, for example, the athlete using the hammer throw event. You have a heavy weight at the end of a tether. The athlete can swing it round and round and round, and it's going to stay in perpetual orbit around the athlete. But the second they let it go, it's going to fly off in a straight line. It's going to continue flying off in a straight line until, obviously, here on Earth, atmospheric effects are going to resist it enough, and it's going to crash back into the ground. But that's always the way without a physical tether. So all these things out in space without a physical tether to the Earth, you can't just say gravity is a physical tether, because it isn't. It never works that way. Earth is going to be flying off into space, leaving these things in our space dust. So satellites are absolutely useless in the heliocentric model. They're never going to work. They're all just going to be thrown up into the air and lost forever. Never going to see them again. A Satelloon, for example, and we know Satelloons work because we've got thousands and thousands of weather balloons all around the place all the time. Even they would be just as useless in the heliocentric model. But if we're talking about something above the stationary planar Earth where everything finds its level due to different densities and everything, then these things will reach a certain point and they'll become neutrally buoyant, and they can sit there for decades if necessary, and can relay electrical signals down to people's radar dishes or satellite dishes. It's so much simpler on the stationary planar Earth than the complicated nonsense and mathematics that don't work with the three-body problem. Simply don't work. It cannot happen on the heliocentric model. It's done its time in the sun and it's finished.
Did you hear me talk about that concept of hyperskepticalness, being hyperskeptical?
I did hear that.
Hyperskepticism. Do you think that skepticism can be brought too far? Is that possible?
Possibly.
Right, because you see the issue that comes with hyper-skepticism, right? If you stop trusting everybody and everything, if you stop trusting all people, then you can't have support from anyone anymore, because you'll never trust anybody.
Well, that's fair enough. But right. You have to draw the line somewhere, and if you are of a logically sound mind, then you can trust yourself. Like, if you question your sanity all the time, as I often do, then that's generally the sign of somebody who actually is sane. Whereas an insane person is most likely not to even realise it in the first place. But the more you question your sanity, the more sane you are. And you don't my logical abilities of deduction to understand what is logical and possible and what is not. It's as simple as that.
So you're absolutely right. You have to draw the line somewhere. You have to figure out what's extreme, and I don't want to be the extreme one, because the extreme means you're probably drawing the line in an inappropriate place. So you want to make sure you're not extreme. Do you think being a 1% category of the population and not trusting the other 99% and the 99% of what they believe, do you think maybe that might be in the extreme zone of hyperskepticism?
Possibly, yeah. I've got no reason to discuss what most people believe about most things. It's just that when it comes down to thinking they live on some spinning space ball hurtling through space, most people haven't given enough critical thought. Okay, they just told what they were told as children. They've never given the time of day to really question it, to really investigate it. Whereas the people who do, they're the ones that become flat earthers. I grew up believing in the globe just like you still do, but I fully investigated it, and eventually I've realised we were all brainwashed. We were bamboozled. We fell for it, but some of us got better.
So I guess I'm coming from the side that if you were, because sometimes I'm wrong about things, right? I could totally be wrong about something.
Really?
And all right. Now, would you ever say you could be wrong about flat Earth? Could you be wrong?
At this stage, no. I mean, there are certain parts about it I could be wrong about, but knowing how the nature of water behaves, and having spent most of my life around the ocean, observing the tides, observing the moon, watching sunsets, knowing everything about nature, spending thousands of hours watching the stars, I know that the heliocentric model is just plain wrong. And the only thing that replaces it is the stationary planar Earth fixed at the base of the universe, where we watch regular patterns reoccurring all the time. It's the only thing that makes sense. So there's no way I could possibly be wrong at this stage about the flat Earth versus globe Earth debate. There's nothing you could ever do to convince me back to believing in the spinning space ball.
And that is the reason why I think science is important. Science only exists because what we think is true is sometimes not true at all. And science is there to auto-correct those self-imposed biases, right? Because once you start putting numbers down, once you start putting equations onto things, those equations are not intuitive by any means. Equations and numbers are always going to be able to find the truth in what reality is describing far better than our mental intuition. Because so many times I'll think I have my phone vibrating in my pocket, and I'm like, grab my phone, I'm like, it's not even there. I don't even have my phone in my pocket. So it's like we have these understandings that are in our brain, these constructions of how the world works, and those understandings can be extremely wrong and completely subject to our own bias, and we don't even realize it because it's our own bias. And that's why you have to push numbers, science, and analytics over your own personal feelings about how you feel something is, even though 99% of all scientists disagree with it.
Well, I 100% agree with the majority of what you just said, because most of these things are confirmation bias. Now, going back to the Eratosthenes experiment, for example, if he had set out to prove that the sun was nearby and local, and trying to measure the size of its path, he would have found that the size of its path is exactly the same measurements as the size of the equator. So there's all confirmation bias when he decided, it's the size of the size circumference of the sphere. There's so many different things when it comes to confirmation bias, and it's exactly what you are doing in the name of science, is using confirmation bias. That's why they had to come up with a theory of relativity, because they could prove no motion of the Earth, no orbit around the sun. So what do? We'll just call it magical relative motion and just pretend we're in motion, even though there are hundreds of scientists who have been quoted that say we could just as easily place the Earth at the center of the universe and everything would still make just as much sense. And so we're going to talk about mathematical proofs, as you brought up. You haven't even come close to mentioning how there could be a 160-mile hump in the 6 feet of drop of the Nile River between where it starts being 6 foot above sea level to where it becomes sea level. 126 miles is massive, and that's your mathematical figures.
Iron Horse, have you done the calculations on it? Iron Horse? Be honest.
I did them myself.
You did them yourself?
Yes.
Do you have any evidence of those calculations you did?
I looked up the circumference or the size of the Nile River.
But do you have it written down anywhere?
I just did it on my calculator. It's pretty simple. 1,000 miles.
Okay.
Would you like to see me do it live?
Did anyone double check your calculations, Iron Horse?
You can double check them for me if you like.
No, I don't want to.
Yeah.
So one of the most important parts of science is peer review, right? Because you can get into your own head. That's great. It's great. One of the most
6,000 feet.
One of the most important parts of science is a concept called peer review. And if you're not participating in peer review, then your scientific conclusions are not considered reliable, right? And you shouldn't even...
So you're not even going to peer review me here live. When you had the opportunity, I just showed you exactly how to do the calculations. You're meant to be the one peer reviewing. I showed you how it's done, how it creates a 126-mile hump in the center, and you refuse to even look at it. So there you go. You just choose ignorance over being able to prove me wrong and peer review me here live when the opportunity presented itself. You just hand wave me away. That's cute.
Peer review is not done in debate. It's done through papers for a reason. It's because in debate, I don't have all the numbers ready. I'm not going to trust your sources, Iron Horse. That's the whole point of peer review. I'm not going to trust all these things you're telling me. Huh?
I am the source. I know the formulas. Yeah.
Right. That's why I wouldn't trust them, because... Right.
Because I don't follow your religion. I follow a different code of belief.
If any...
Heliocentric cult of the 1500s.
if anyone was trying to peer review anybody else, the whole point is to not believe your words and to go validate it somewhere else. It takes hours, days to peer review anything. So this is an inappropriate place to.
You tell me then, how would you calculate how much curvature drop should exist in 1,000 miles?
I would have to look up a lot of different geometry and to try to get those equations for you. This isn't the moment for that.
You both don't know your own belief, whereas we can, let it ring off.
Iron Horse, you didn't know what the equation of Iron Horse, you didn't know the
equation for curvature.
You didn't know the equation of buoyancy. Buoyancy. You didn't know the equation of buoyancy. It's three numbers multiplied with each other.
Multiplied by zero, which is
buoyancy is a stupid equation.
That's the curvature calculator. The most important part about your spinning space ball is the amount of curvature which should exist over a particular distance. And if it doesn't exist, there must be somewhere over there, out of sight, out of mind, where it compensates to continue making it into a sphere again. We can't find anywhere where there's actually curvature. So almost as though it keeps on going flat, until eventually it reaches the point where it turns into a cube Earth, and you just flip over this 90-degree bend and you realise you're back on the flat again. There's no curvature anywhere. So in order for the Earth to be a sphere, it has to be a cube. That's basically the logic you have to deduce when it comes down, because you don't even know your own curvature formula.
So let me ask you a question about the number. The number that you got was very big, and that's the reason why you don't think it's good number, right?
It's just basic mathematics.
No, why do you know it's wrong? Why do you know it's wrong?
I don't know it's wrong. Because water doesn't flow up curve. It doesn't flow up 100 miles of curve. It doesn't flow up a meter of curve.
You're talking about it doesn't curve down that much, right? You're saying it doesn't curve down that much, right?
You're talking between any 2 points. Like if you look at that fantasy ball behind you in the background, let's take our far left and our far right. In the middle is a big hump. So if water was to flow from one side there to the other side, it's got this big hump in the middle. It has to flow up and over to get there. That's what I'm talking about. If curvature existed, it creates a physical hump, which water does not flow up and over. It only flows down topography, and that only works on a flat Earth.
I guess the point I'm getting at is the end of your conclusion of the equation was that this is a very large number. This number is too large. It shouldn't be this large. That was what kind of the conclusion of what you're saying, right?
No, I'm saying it's exactly the number it should be, that it has to be, in order to have a globe with a 24,901 mile circumference.
Right. So how do you know? So how do you know it's not true?
Because water don't do that.
How do you know it doesn't do that, Iron Horse?
Because water only flows downhill. It does not flow up curve, as I just explained to you. It is impossible.
I guess that's the whole core disagreement we have, isn't it?
That's right. That Earth exists because we understand the properties of matter, and water is one of the most fundamental properties of matter that proves everything we need to know, that the Earth cannot possibly be curved. Water doesn't curve. It does not stick to the sides of the ball. It does not stick to the undersides of the ball. It does not adhere to.
I mean, you're just describing your.
Properties of anything.
You're describing your.
Describing reality.
No, you're describing your assertions. I know those things are not true. If you wanted to describe evidence that proved those assertions, that would be more productive. But just saying the assertions don't really help anyone look at that as more reliable information.
Well, if I was able to upload my images and share a screen, I could easily show you. But as I described before about the model, we can make a model as long as the sides of the dish are higher than the water level, it will always hold water. A globe, a ball, any size and shape will not hold water. In fact, some idiot the other day tried to tell me, but I can soak a basketball and it would have a layer of water all over it, which would be greater than all the oceans. And I said, yeah, terrific. The standard classroom globe says that our entire atmosphere is no thicker than the layer covering. So if you had a thin film of water over something the size of a basketball, you'd just drown the whole world in about 80,000 feet of water. That's the equivalent at scale. Anything made to scale, a model should scale. We can make a flat Earth model at any scale and it will work. You cannot do that with a ball at all, ever.
Right, but I mean, when things get big, things act differently when they get bigger.
Of course they do, yeah. The
Yeah.
power of big.
I mean, you know, when you get higher in the atmosphere's density changes, right?
That's right, because same as water pressure, there's less atmosphere above you, so there's less air pressure. Plus, air itself is made of different molecular
Right, but you don't.
as opposed to
But you don't.
water. So
You don't account for those.
Yeah.
But you don't need to account for that density change when you're on like a local scale, right? Because it's inconsequential when you're talking about like a small scale type of an experiment, right? The
Well,
difference
I mean,
between a large scale and a small scale change.
5 miles isn't exactly a large change in distance, and yet if that's about the height of Mount Everest, 5 and a bit miles, and people up there need extra oxygen assistance. So it actually changes pretty dynamically, pretty quickly. So
Right,
yeah,
but if
same
you're
time
talking,
because it's big.
but you understand the difference between a local system and a global system. The rules change. Like if you're talking about designing something pressure related on the surface of the Earth that's never going to go above 100 feet, you would design it differently than if you're expecting it to go over 1,000 or 10,000 feet high, right? You would design it differently because the laws of physics are different when you go on a larger scale, right? You understand how that could be different.
And that's why we live on a stationary planar Earth fixed at the base of the universe, because everything finds its place according to the laws of density, including the atmosphere. And we live at the base of the atmosphere. That's basically where human
again,
biological life, it's physical life.
Yes, it's
We
just
don't have to account for being 10,000 feet in the air because we don't live 10,000 feet.
But if you were designing something small, you wouldn't account for a density difference. But if you're accounting for something that's going to be big, you would account for a density difference. You make different assumptions based on what you're trying to do. If you're going to do something that accounts for the big difference, you'll make a big difference. If you do it small, you don't have to worry about it, right? You don't have to worry about the curvature of the Earth if you're making a house that's going to be, the size of a normal 5-person house. But you do need to account for the curvature of the Earth when you have miles and miles and miles of pipe that are going to extend from one continent to another, that extends electrical conduit, right?
Absolutely right. Then the first example that was ever introduced to me was actually the Suez Canal. And my ex-father-in-law was a merchant sea captain his entire life. He'd navigated the world multiple times. And after he'd retired, he says to me one morning, sitting there having Sunday morning coffee, reading the papers, he says, "I believe the Earth is flat." And I thought he'd gone insane at the time. I thought, that's the most ridiculous thing I've ever heard. I said, "What would make you say that?" And he brought up the example of the Suez Canal. And the Suez Canal is a go-to flat Earth proof because it is over 100 miles long. And at the time I said to him, 100 miles, that's not big enough to see Earth's curvature. Well, once you do the maths and realize how much curvature should exist over 100 miles according to the size of the Earth that we're given by Eratosthenes and modern disciples of the spinning space ball, there should be some over a mile of curvature drop from one end to the other. And so when you put it the halfway point in the center and say, okay, that point there should be half a mile of curvature drop. The world's tallest building is the Burj Khalifa. It is a massive, massive building, and it is 1/2 a mile high. So if you put a Burj Khalifa in the middle of the Suez Canal, that is how much curvature drop should exist in the hump in the middle between it. Otherwise, there's about 3 of them in drop from one end to the other. So which boat's going up curve, which boat's going down curve? None of them do. They're all on the flattened level. That's how we know the Earth is flat.
So let's say if you were on that globe and you had a straight line that was trying to go really far and it would extend over that curve, what would that look like, Iron Horse?
On a globe?
Yeah, what would it look like if you try to extend a straight line really far over the horizon, down over the curve? Can you imagine in your brain what that would look like?
Absolutely nothing like what things do look like in our current perspective. And in fact, I think that's a mental illness to be able to even try and visualize it. The best way to do that would be to, say, get a ball, get some little plastic things to glue them on, like a fence or something, or telegraph poles, and do it. And that's how you'd see it happening. You wouldn't see the bottoms always rising up to eye level in the first place. You wouldn't see the tops ramping down to eye level and beyond because they're higher than the convergence point, which is exactly how
let's be intellectually honest. I don't think it's a mental illness to try to imagine a possibility. I think that's a little bit rude to say. But if you could imagine it, and if we could try to think of what that would look like, if something curved over the edge of a earth, if something was really straight and curved over the edge, if I then showed you an image that looked like the thing you were imagining it would look like, if I showed you that image, would you then say, oh, that is what it would probably look like, and maybe that does support a globe Earth of a curvature, right?
Is this going to be a Lake Pontchartrain image?
A what? Like
Lake
that's one of them. There's others. The point is,
There's others?
if it looked, oh yeah, there's others. The point is, if it looked like the thing you expected it to look like, that would support that idea, wouldn't it?
But it doesn't look anything like it if you open up your mind to interpret it properly, is that it's just convergence. You can see, as I said, the bottoms are curving upwards first, but the tops are curving downwards first. That's not how it happens. It should start everything curving down immediately from the eye of the viewer, not going upwards until it reaches the horizon for things that are beneath your eyes.
But again, you have to start. These are the kind of things that you're like, oh, it doesn't make sense if you just think about it properly. That's the reason why math is important, right? You can't just label properly. You can't label properly as right and say, I'm doing it properly, so I'm right. You have to show it. And saying, oh, it just doesn't make sense because if you think about it this way, you have to actually show it, because you're not even talking about quality things anymore. You're talking about geometry. Geometry is a mathematical concept.
That's you. You're talking about rubbish.
Oh, I am. That's right.
Geometry, but geometry has no place in perspective whatsoever. Geometry is completely two-dimensional. You can make it look a bit three-dimensional, but it never is going to be. But when you're looking at something three-dimensional, perspective overrules geometry 100% all the time.
What do you think geometry means? Geometry can be three-dimensional? What are you talking about?
Okay, so you build a three-dimensional timber equilateral triangle, a big playground instrument. It looks exactly like an equilateral triangle from standing in front. But you start walking 10 feet to the left or to the right, all of a sudden now it's no longer an equilateral triangle, is it? Up here it is, because you're understanding it properly, you know it is. But from perspective, it's nothing like it. And that's what you have to understand with perspective, is nothing is as it seems. And you cannot use simple geometry to try and explain it. You're absolutely wrong. You're using confirmation bias and fooling yourself, which is actually a type of mental illness, sorry to tell you.
That is extremely rude, Iron Horse, but I'm going to forgive you. I'm going to let that pass this time. Well, as long as you said no offense, then I guess it's fine. So geometry absolutely is used in determining certain perspectives of things. Like if something is very far away and it's a certain shape, and you know how the shape should look, you can then use geometry to determine the orientation that shape actually is, because you can use geometry in perspective.
It's got nothing to do with the orientation of it. What are you talking about?
What you just said, if you put a triangle equilateral and then you look at it from the side, it's not going to look equilateral. Well, you can use math to determine the exact angle you are looking at that triangle at. And that math is called geometry.
But it's not going to make it that the triangle that it appears to be, though, is it? That's the difference. You know, what things appear to be aren't how they are. That's what perspective is all about. You're trying to use simple geometry to try and explain things that are all optical illusions. Everything's an optical illusion. All of perspective is.
Geometry is used to describe those perspective distortions. That is how all of optics works.
Geometry overcomes those distortions by putting it in pen and paper or putting it, pencil on paper on a 2D surface. So you've got a fixed understanding there. It's like when you take a photograph, for example, that's a fixed image. You can look at it from any angle and it's not going to change. But if you go outside and look at the same view and you change your angle looking at different ways, it changes entirely. Parallax is a real thing in the real world all the time, which cannot be represented in simple geometry, photography, or anything like that. It's a real world phenomenon.
So I'm like extraordinarily surprised. Like, this is the entire field of optics is doing what you're describing. Optics, almost all of it. Optics. Optics is the thing you're describing, and optics and geometry go hand in hand. Almost all of optics
No.
is geometry, and you have to figure out how
That's the
light
biggest
will bounce in certain directions based on the certain substances it's going through and the angles that you're looking at things.
mistake you're making, because the Earth is a dynamic system where everything is constantly changing. Nothing is fixed. But as soon as you make optics of it, it's like I say, you're taking a photograph. It's just the still of a moment in time. But everything is constantly in flux. Everything is constantly moving. The sun is never where we think it is. You know, people think they can triangulate towards an optical illusion of light in the sky that's in a completely different place from another person. But the simple geometry will tell you then it's 93 million miles away, when in actual fact, each person's individual apparition of it might be only 12 to 14 miles high. You know, that's the whole problem with assuming that simple geometry and mathematics can describe things that we see visually, which are all optical illusions. So that's why everything about the globe is so fundamentally wrong, because it assumes everything is just fixed material, one view solves all. It's not. It's a completely dynamic system where everything is different for every viewer everywhere.
So it's almost like you're describing in a way that it could never be understood with any form of math, right? Because it's so dynamic, there's no way you could make any prediction about anything, right?
No, that's right. That's one of the things you have to learn to live with. That's life.
This is called this. You see, you're living in this world where the entire world is basically an unfalsifiable claim. So nothing anyone will ever. I mean, you even said it that nothing will convince you, but you're now saying nothing should ever really be knowable because everything changes. So there's no consistency in the universe. So don't even try to measure it because it's going to change tomorrow anyway. There's no consistency in any which way possible, right?
Well, that's part of it. Exactly. You have to be able to comprehend that in your mind, that these things aren't knowable. They're not something you can fix and measure. But you can still.
But you can know it's flat.
Yeah.
But the one thing we do know is that it's flat. That's the one undeniable truth that will always be true.
I can predict a jug of water. I can predict that whatever it hits, if it's not going to contain it, it's going to keep on flowing until it hits another level. So I can predict by the nature of water what's going to happen, and that tells me that the Earth is flat.
Okay, so there are some things that do stay the same, like the nature of water.
It's still going to have variables. It's still going to have variables. You can have a pretty good idea what's going to happen.
But can you use it to make... Okay, the whole point is, can you make any predictions using your assumptions? Can you make predictions at all, or not?
You can make some simple ones, yeah, of course.
Exactly. If you can make predictions, then it becomes useful. And that's why all of science is based on that fact. If this idea we have makes a prediction, and that prediction turns out to be true, that idea we just had, we're going to basically call it right until something proves that prediction was false. That's what all of science is doing all of the time. And you have this idea that almost everything is not that way, but just like with the water, if the water consistently does it right here in front of my face, then it probably does the same thing on the other continent. And you can make those assumptions, even though they are assumptions, but they can produce valuable predictions that you can completely change the way you perceive the entire universe. But you think that everything is just random.
What I expect them to do. That's exactly what I expect them to do on any continent, anywhere on the stationary planet Earth. Water is going to do exactly the same thing. I predict that what it does where I pour something out is going to do the same as where somebody else pours it out. That's really simple. When I go and make other predictions, for example, about how the sun and our vision of the moon works, because of my experience with decades and decades of actually observing it myself and putting the models together and analysing all the data that we've got in this latest century of, most digital cameras are probably less than a decade old, or very little more than. Since we're in this last decade, the amount of information that has come to hand that can now be analysed to fit a model, I can make a working model that matches the observations, which is exactly what you just said. If it matches the observations and it's a good theory, well, until somebody comes up with a better one. See, I say the nature of light. There is no light. Even in your picture you can see there's no light in the darkness of space. The atmosphere itself is the giver of light, and that's because of the atmospheric gases that get fluoresced by the solar radiant energy. So all light itself actually comes from the Earth. It's powered by the sun, but it's in the atmosphere.
you just said you could make a model that describes all those observations, and it'd be a flat Earth model, correct?
That's correct, yes. Absolutely. Okay. And as I say, that each of these things that creates the influence that creates the light, you see through this veil of the atmosphere, and that's where you see the apparition of that light, and that's why it will seem to move with you as you move. Everything.
Iron Horse, why haven't you done that?
I have. You can see my channel. I've got a playlist. I've got a playlist channel called Whiteboard Lessons, and I've shown exactly how it works. What do you mean?
But
I'm not a
usually,
maker. I just nature appreciator.
Okay, right. You haven't made the model, right?
I don't need to. The model's already made. I live in it.
But no one believes you, Iron Horse. So make the model. Convince people. So why are you debating?
The model's already made. What have I got?
Do you know what a model is for, Iron Horse? The purpose of a model, what the purpose... You just said you could make a model to show how everything works. Why don't you make the model to show everyone how it works? Because I don't believe you, and if you showed me a model, then it'd be something to work with, right?
Okay, well, here's a thought experiment model for you that might come even close to even a tiny fraction of a second of scale. If you've got a massive, massive stadium, one of those huge football stadiums, that's mostly enclosed, doesn't have to be fully enclosed, but somewhere across the middle you strung a spotlight. And then say about 3 meters above the surface of the ground, you spread out this massive sheet. So it's a massive sheet, say a blue sheet, suspended in the air, hopefully as flat as possibly can be. You might have to use poles and springs and whatnot, but stretched out as tight as possible. Now, you have the spotlight shining from above, the entire sheet looks as though it's lit up. But from below, all you get is this gentle blue glow, and you can see a hot spot of the spotlight through the sheet. So if you started walking around, that spotlight is going to follow you. So no matter where you were looking up through that sheet, that's where your version of the spotlight is. So you could have 1,000 people down on the ground, all in different spots, and each of them are going to see a different spot where they see the hot spot of the spotlight through this sheet. That is basically how light works on the Earth, is that the atmosphere is the sheet. The sun is more like 60 to 70 miles high. The sheet is about 12 to 14 miles high. And everybody's looking through a different part. Except the sun is never anywhere in particular. Now, that's just one snapshot of one moment of one day. Then if you put the whole sun in motion, around the 25,000 mile circumference working system, where the sun, when it comes into view, will appear to come up until it's overhead. Then as it goes away, it'll appear to go down, all due to natural perspective. It's not rising or setting or going beneath anything. It's just a massive model on a massive scale that our minds aren't capable of quite comprehending. We're like little dust mites in a shag rug. If somebody ran the vacuum with a light over the front of it above this rug, to the dust mite, this light would appear to rise into view and then set again as it went out of view. But only the dumbest dust mite would think that means the rug is a spinning ball hurtling around the light.
So in what part of that model would it appear that the spotlight goes halfway under the horizon?
No, none whatsoever. This is just a single snapshot of a single moment of the day. People 1,000 miles apart from one another looking up at the sun.
I mean,
in the daytime.
That's the thing. I agree with you. I am actually going to agree with you about this, Iron Horse. The Earth looks flat when you don't consider all the other stuff that makes it not look flat, like sunsets. Yeah, it looks flat. If you just stand here and look at it like a snapshot, it looks pretty flat. But you know what else would look flat, Iron Horse? Iron Horse, you know what else would look flat? If you were on a really, really big sphere, so big it's almost mind-boggling to understand how big it is, and that would also look flat if you're on the surface of a really big sphere, right? Would that be true, Iron Horse? Would it look flat if you're on a really big sphere?
I guess if your mind is that boggled, yeah, but we understand the properties of the size of the ball of a sphere's circumference of the size you say it is. At 25,000 mile circumference, at 100 miles, you got over a mile of curvature drop, which is more than 2 Burj Khalifas of drop. And we can see for hundreds of miles without so much as an iota of drop, not a single bit. So no, it's not mind-bogglingly big. We understand the actual parameters of your belief. And we know it's not that big. You are the one that's mind-boggled by your own beliefs. But it's the flat earthers come along and give you a sense of reality, show you what you really live on, and all you can do is go into denial mode.
Well, the thing is, Iron Horse, you aren't even familiar with your own physics of the number one most influential force in the universe from your perspective, which is buoyancy. You don't know that on the most basic of scales. So
Absolutely, that's how
that in combination,
my model is based on that. Come on, you are lying through your teeth, and I'm not.
So that in combination with you never showing real mathematical calculations beyond putting a calculator to a screen, and not having not even trying to get any real form of peer review. Not even trying to have any real form of peer review. It shows an almost lack of good faith.
No, you had your opportunity and you were too cowardly even to investigate. You were just like, I don't want to know the calculations of my own belief. You're in denial about it all. That's all you guys have to do. You're in denial, excuse. Inertial reference frames, conservation of momentum, all this other bullshit. None of it works. It's all just excuses for why your model doesn't work. Ours is obvious, straight to the point, no nonsense. What you see is what you get.
If it was, yeah.
I know that, William, I know you've got a round in the chamber ready to fire back, but we have to give somebody the last word, and I'm inclined toward, just because it's been a little bit over 2 hours.
It's no problem.
It's a good time to jump into Q&A, if you feel like we're ready, if it's a good time as well, William and Iron Horse.
That's perfect. No worries.
My volume is so low. Let me see if I can turn this up. Thanks for your feedback in chat. Someone told me.
It's been 2 6.
I'm going to work on this here. Check. 1, 2. How is it so low? Let me see what I can do here. 1, 2. That one doesn't make a difference. Let me try this one. 1, 2. Let me just double check that I've got the right one plugged in. Oh, I think that might be it. How embarrassing. No, I did have it. We'll figure this out. Bear with me, folks. Oh, there we go. Here we go. Thanks for your patience. All good now. Housekeeping stuff. Before we go into the Q&A, a couple of quick things. Folks, if you didn't know, we have memberships here at Modern Day Debate. If you can't make it to DebateCon 7, which is in Houston, January 31st, you're like, oh, man, I'd love to do it, but I can't make the trip. You can watch the entire debate, the entire conference from the comfort of your very own home live. If you become a channel member, check out our memberships. There's the spectator level. That's just $2.99. There's the debater level, which is just $5 a month. And then there's the final word level, which is the one that you would get to watch all of DebateCon 7 with. And if you have a gifted membership from somebody else, what's really cool is you can actually just cover the difference. So let's say you have a $5 gifted membership, which if you did get a gifted membership, it's at the $5 level. Basically, the way it works is you just have to put forward another $10 to upgrade, and then you get to watch all of DebateCon 7 live from home. Now, other quick stuff. Thank you very much. Appreciate that super chat that just came in from Big League Drew. Big League Drew, thank you so much for giving those gifted super chats during the stream. We're going to jump into it. I have a feeling most of these are going to be for Iron Horse, so it's okay that William is in the other room for a second. We're going to get it rolling here. Cake Hans, thank you. Says, for the fun of this debate, can you all, including you, James, please tell me your favorite pizza? Example, mine is taco pizza. Yes, it's messy. I don't care. I love pizza. All pizzas. I'll get the ball rolling. I'm very pleased by a pepperoni. Even more than a meat lover's pizza. 'Cause those are good, but I just like pepperoni. Just really goes well. Gentlemen, what's your favorite pizza?
So right now I'm on a diet, so I need to replace the crusts with some protein, and I've heard if you use chicken as a crust, that is going to be my favorite pizza, right? Like ground up chicken, use that as a crust, and then put cheese on it and pepperoni. That's what I want right now.
Can you do that?
I've seen it on TikTok, so probably.
Wow, that's cool. I've heard.
True.
I've heard of cauliflower instead of Yeah,
That's also good.
But chicken,
That sounds less protein,
but chicken sounds even better.
right?
So yeah, what about you, Iron Horse? Pizza, favorite pizza?
Yeah, I just make my own. Throw in whatever, mostly veggies and a bit of chopped up chicken, heaps of garlic and onion and a bit of pineapple, whatever's got handy.
Wow.
Pineapple?
This
That's
one,
a hot take.
Absolutely.
This one from
Olives.
LJ says, "Why doesn't Earth spin under a hovering helicopter?"
LJ. It's called the conservation of angular momentum. It's the same reason you can fly a drone in a bullet train. It can hover, but you're moving over the surface of the Earth. And it appears still. Is also another word for that is an inertial reference frame. The helicopter is an inertial reference frame, and the Earth is under it and partially moving because the helicopter's moving. So look up inertial reference frame. Maybe that'll help.
You got it. This
That's
one
a
coming
really,
in
really, really sad. Can I have a quick go at that one? Because it's a really poor analogy.
I'm just a little bit nervous about rebuttal.
Just this one.
Okay.
Just a really quick rebuttal is that
Just
when
this
he's
one.
talking about an inertial reference frame and comparing it to a bullet train, he's put it inside a bullet train where the air is pressurized by the back of the cabin. If you're going to make any comparison, get on top of the bullet train and show us how you go.
This one, if you had a quick, I can give you a pithy response because the question was originally for you.
Oh, okay. The atmosphere on the Earth is pressurized, Iron Horse.
Marilyn says Earth.
By the back of what?
Says Earth with an F, flat. Thank you, Marilyn. This one from In Their Shoes, Apologetics says, when James said, if you've been living in a cave, the flat earther felt it. Ross, it's, you've got this big, tremendous beard. It's people admire the beard. Kay Khan says, finally, a debate that landed on my payday. I've been wanting to throw money at you. I love your channel, James. Keep it up, bud. You're killing it. Thanks for your kind words and your support. And all credit to the speakers who are linked below. So, folks, if you haven't checked out their links yet, now is a perfect opportunity. They're the lifeblood of the channel. This one from Big League Drew says, what do you think about the observed 24-hour sun in Antarctica?
Before that even happened, I'd sent off a thorough description of how that's possible on our stationary planet Earth. You just have to understand exactly how a model works, which isn't something I can answer in a 30-second soundbite. But when you do understand how a model works and why the stars appear to actually go the opposite direction, the 24-hour sun makes perfect sense on our model.
You got it. This one from Do Appreciate It. Big Lee Drew says, what does, quote, level, unquote, mean?
Level is that for you? You will.
I don't know.
They don't say who it's for. I'll give you both a chance.
Level means straight from your local perspective. It means that when you take a level, you want to balance the air bubble in the middle so that you make sure it is not tilting one way or the other. That's what level means.
You got it.
Okay, well, the dictionary definition of level, I think I said we're both getting a chance, is that it has multiple different meanings. There's at least 13 or so in the dictionary, or actually more than that. The dictionary has multiple different meanings of level, and the word flat is used more than a dozen times. But the difference is when we say level, because it has so many meanings, if we say flat and level, that gives it a whole new different meaning, just like if we said something is red and hot. Doesn't mean all red things are hot and all hot things are red. So it doesn't mean level is always flat, or flat is always level, but flat and level is always flat and level.
This one coming in from, do appreciate your question. Bless My Vibe Code says, Iron Horse, aren't you a little old for this outdated trolling? It's not funny anymore. Flat Earth used to be funny like 10 years ago. Now it's just cringe.
Yeah, I agree. It should be so mainstream by now that everybody should be on board. We've had a decade of it, and still we've got all these stragglers dragging their knuckles, still pretending they live on a spinning space ball. It's a bit sad, I agree.
Yeah, William. This one from, appreciate it. Bless
Brutal.
My Vibe Code. Oh, we got that. K Khan says, Iron Horse, well, I believe the Earth is spheroid. I think it's important to have people like you to challenge what others accept as common knowledge. Without people like you, we would all be sheeple instead of people. Iron Horse, what do you think?
I think the people that still believe in the spinning space ball and not by now actually should be rightly referred to as sheeple, because they are. They're just following the crowd. They just want to go along to get along. They're afraid to pop their head up above the rest of the others and be ridiculed for their beliefs. Throughout history, virtually everybody who comes up with the accepted science that we have today was absolutely ridiculed and shunned by their generation of people at the time. So for people who are always making advances in science, they're never liked at their time. Everybody disagrees with them, hates them, and so that's just one of the prices we pay when we know the truth. We will go dying with our books in our hands like the martyr, so to speak.
Got it. This one coming in from Max M says, Iron Horse, you also believe in Bigfoot.
Why didn't we debate that?
Yeah. I think it's entirely possible. We have our version of the Yowie here in Australia. And
I was about to say, an Australian Bigfoot?
Wow.
Yeah, the Yowie.
I did not know this. Okay, so in Australia, there's your own version. You call it what?
A Yowie?
A Yowie.
Y-O-W-I-E.
Yowie.
Dark looking. So it is kind of, it's interesting. This one from Max M says, we got that. K Khan says, James, Max isn't skimming viewers. He's just pandering to the monopoly you hold on the majority of people that enjoy good debate. Go to the after show. He will drop the link later. Yerba Mate Talks is running an after show, and we'll get to his plug in just a moment. Jonathan Tessier says, Flurf, how is it to be exposed as a grifter scamming people under the Dunning-Kruger effect? Or should I believe that you are regarded?
Man.
It's so funny that most of the people that will bring up this Dunning-Kruger effect are actually the ones that they're talking about. Very few people who are on the far right of that would even consider it. They sort of assume that most people are close to their level of knowledge. But the ones who use Dunning-Kruger effect all the time and call people names, they're the very far at the top left. Most people understand that the more you know, the more you don't know. So these people are so confident in their beliefs, they're top left.
So I'm sort of got to say, no, you!
This one from, do appreciate it. Trust Cow says, always tune into Flurf debates, hoping the Flurf, like Iron Horse, will have an argument that isn't based in willful ignorance, conspiracy, or science denial. Disappointed once again, but at least it's entertaining.
Everything I've said follows the laws of physics. There's a density gradient. If you look up specific gravity, the very term will come up straight away and say specific gravity is relative density. That's all we need to explain the observable laws of physics specifically.
You got it. And thank you very much for your kind words, Jonathan Tessier and Trust Cow. Thank you so much. Tango44 says, hi, James. This is Ross's care professional here from Perth, sunny side home for the impaired. Could you please ask him to go to the day room when he's finished playing? Iron Horse is not amused.
It's a bit of a long walk, like Perth is thousands and thousands of kilometres away from where I live, so I guess I must be a bit lost up here in the forest.
Big League Drew says, how do you explain a Selenelian? You guys let me know if I'm saying this wrong.
Selenelian.
Thank you. Selenelian eclipse. Just so, and can you explain what a Selenelian eclipse is, please?
Yeah, so a Selenelian eclipse, I love to talk about it because you have a lunar eclipse while you can see the sun and the moon in the sky at the same time. So intuitively, you'd be like, that can't happen, right? Because that's being opposite sides of the planet. The thing they don't tell you is it is only and exclusively when the sun is on the horizon or extremely close to the horizon, and the moon is also on the horizon or very close to the horizon. It's almost like it's on two opposite sides of the Earth. And since they are very far away, the perspective of it being higher than the Earth is what you would expect to see. So it's only when it's on two sides of the Earth is when that can happen. And that's what would happen if you had a lunar eclipse while you're on the boundary between the Earth and the Sun and the Moon. That's what you'd expect.
No perspective when it helps you.
This is how have I not heard about this after hosting so many flat Earth debates? This is crazy. So, folks, you have to check this out. I've never seen this before. I don't know how, but this is really cool. Google it if you have not yet already. I'm going to put this in the live chat because the concept just by itself, regardless of what side you think it supports, is just so cool. So yeah, I'm going to put that in the live chat. Now I know like 99% of the live chat is like, yeah, I've known about that forever, James. But thank you very much, Pablo, for your super chat. We're going to get to that shortly. This one from Cake Hans says, Rage Bait, dangle, was the moon landing fake? Better prove it for both. What do you guys think? Short and pithy, like yes or no, plus 1 to 2 sentences. Why you think so on the moon landing allegedly being a hoax?
Absolutely fake because of the amount of air you would require every time you repressurize, the amount of pressure which would exist inside of your suit, which would make you blow up like the Michelin Man. And for 3 days and there and back, the amount of air required is just not possible to carry. You need to be 10 times more than the fuel to carry.
I feel like your explanation should just be that the moon doesn't exist, so the moon landing couldn't exist. But so the moon landing did happen. Even our enemies said it happened. So it's hard to convince them to lie for us, but they did. So
this one from, do appreciate it. Max M says, question for Iron Horse. Why would all governments lie about the moon and the globe?
I don't think they're necessarily lying. I think they're just going along to get along. It's got really nothing to do with the governments themselves. You know, there's a few almost privatized military agencies that are involved with space and everything. But I don't see why anybody is lying about anything. They're just equally bamboozled as the rest.
Okay, this one from King044 says, hi, James. This is Ross's Russian handler. When he has finished reciting his script and helped spread conspiracy thinking to aid the erosion of Western society, can you ask him to go to the day room? Now, Ross.
I love the day room. It's so much fun.
got a lot of board games.
Little pills and happy smiley faces.
Happy people come over and say hi.
Jim Daniels says, says, sorry for being tardy. The debate have a topic or just a person in pink rambling on about nada?
You leave my pink alone.
That's the best part of the debate.
It's a Valentine's Day, which, by the way, I just realized I've never done like I have to get like a cool Valentine's Day overlay for modern day debate because will join you in celebrating Valentine's Day. We don't care if it's commercialized. There's never a bad reason to love someone. Okay. This one from Cake Han says, that's all my play money. I was happy to spend it here. Thanks, Cake, so much. Says, hey, James, please come to either Fargo or a city in Minnesota. I'd love to attend a debate con in person. Right now, I can't afford that far south. Hey, Minneapolis could work because it's not as big as like Houston, but like Minneapolis is a big metro with St. Paul right next to it and the broader metro. So Jim Daniels says, oh, we got that one. This one from Lando says, I'm just waiting for the TikTok videos of people climbing the ice wall and fighting the ice giants. This one, thank you for that Game of Thrones reference. This is from Geo. By the way, in chat, let me know your favorite Game of Thrones character. Geo says, explain Foucault pendulums.
Iron Horse.
Yeah, well, the pendulum is actually the psychic medium conjurer's tool of choice. It's basically something that they use to try and it's a divination tool. The thing has to be started, bush. There's no reason why on the energetic Earth with a toroidal energy system going around us that sort of follows the sun, that there wouldn't be some sort of drift happening anyway of all sorts of things in free motion. It doesn't prove we're on a spinning space ball whatsoever. Yeah.
What causes the drift?
It's crazy. In fact, if you look at the pendulum in the Louvre and you look at everything around it, surrounded by black sun imagery, and then in the background, sitting on 4 pillars, is a dome surface with some saintly-looking figures on it, sort of giving the whole game away. The drift is just basically, as I said, the energies that are created by, as the sun goes around above us through this toroidal system, it carries a certain energy with it. And that's what everything reacts to.
Sounds like you have no idea what causes the drift.
This one
the sun.
Energies.
Jim Daniel says, Bob Nodal, rest in peace, proved the Earth wasn't stationary with his $20,000 ring laser gyro. Thanks, Bob. Hip ya. Hip ya. I don't know.
Yeah, well, in actual fact, what happened is that somebody donated a 16K gyro for the sake of this mockumentary where things were carefully edited about him. But the 15 degree per hour drift is, as I described in my opening, is to do with the sun. Once again, the sun drifts exactly 15 degrees. And that was one topic I would have actually liked to discuss in more detail, why it doesn't drift 361 degrees in a day in order to match the globe system. It matches exactly the 360 degree cycle on the stationary planar Earth that we see the sun doing. And that's 15 degrees per hour times 24 is 360 degrees per hour, one full cycle. So thanks, Bob. Legend.
This one from Do Appreciate Your Question as well. John says the Earth is flat. He was there when it happened. Oh, wow. You're a wise man, Ross.
I saw that.
This one from Yerba Mate Talks says, after show on Yerba Mate Talks, open panel, let's discuss the debate. Thank you, Max. And Mad Apple says, I'm going to read several of these in a row. They said, you stopped doing flat earth debates till now. I'm still mad about it. Whatever, do more flat earth debates. It was not a question. Do more flat earth debates. You're welcome. By the way, folks, we have had a lot of interest. Like, people have really enjoyed this debate tonight. I got to be honest, I was a little bit nervous because I was like, we haven't done this for a while. I was like, are people going to go for this? But you guys have had a good audience tonight. I think we peaked at about close to 400. It was about 380, 390. And folks, if you want to debate flat earth or globe earth, email me at modernaydebate@gmail.com. We will get them going again because, like I said, there's been a lot of people have enjoyed it. So it is entertaining, to say the least. This one coming in from Jim Daniels. This question for Iron Horse. After many decades of aviation, the ice wall has never been seen. Ice floats. Explain how it holds back billions of gallons of water.
Okay, that was 2 questions. The first one is that flights go the most economical route between 2 places, and because the entire world is surrounded by the ice wall, there's absolutely no reason to go anywhere near it, unless perhaps you're catching the trade winds from Sydney to Santiago, Chile, for example. You might go a bit close. But other than that, there's no reason to go anywhere near it. You know, fly south and keep on going. And the second part of that question was, remind me again.
The second part of the question is, thanks for that feedback on my audio, folks. They said, where is this? Ice floats. So explain how ice explain how ice holds back billions of gallons of water.
Okay, so we're not in outer space to begin with. We're fixed at the base of the universe. The ice is most likely attached to land masses anyway, which are the edge of the container. And even if it was just floating ice, because we believe that Earth is potentially infinite further beyond it, the same water would still be the same level amongst all those other continents as well as it is here on Earth.
This one from Do Appreciate It. Bless My Vibe Code says, Iron Horse, you have 1,240 subscribers, 1,000 videos taken directly from your channel. You're not trending, buddy. You need new content. Flat Earth isn't funny anymore. Find a new conspiracy. There's tons.
Well, the thing is, I don't rely on making videos to trend. None of that stuff interests me whatsoever. And where I'm living now, as you may or may not have noticed, probably why I've got a pink screen, is I'm on satellite internet, which means there's a satellite somewhere up above me. And anytime I try to upload anything, even a 5-minute video, it cuts off my internet for whatever reason. I don't know why uploading to YouTube does that. So I've really got no interest while I'm living here to even bother trying, because I know it's going to be an experiment in fact anyway. But I can still be honing my ideas and concepts and still learning the whole time until eventually I might one day get to the point where I can make video in proper graphic representations and actually make the things that I can visualize in my head. But until then, I'm quite happy to retain a thought experiment and argue it on Facebook and Quora.
This one, do appreciate your question. Coming in from Jonathan Tessier, says, Flurf proved the Earth with lasers. See beyond the curve. Okay. Tide of a Molecule We Once Knew says, hey, gents, I don't watch much because I'm wrapped in other details in life, but Matt, the brother man, says, hi. Anyone play Call of Duty Mobile? I wish I did, but no.
Sadly, no.
I don't know what's hip anymore. But this one coming in from Geo, I mean, we obviously know Iron Horse doesn't. This one from Geo says, geometry has no place in perspective, is just about the stupidest thing I've ever heard.
That was a pretty bad one.
I think that if you're going to say that, you don't understand perspective whatsoever. Because perspective is literally called perspective because it's all to do with the angles to your eyes as opposed to what is actually there. If you change your perspective, geometry changes with it. It's called parallax. To consider that you could use geometry in any way whatsoever to explain perspective would mean you're wasting your time. Just go out and see it. That's how you do perspective.
This one from... Oh, sorry, the page is reloading. 2 seconds. Amateur hour over here. Next, Kango44 says, James, are you not embarrassed hosting these idiots? And it's embarrassing watching people like Ross. Whoa, come on. First of all, how dare you insult your father, Ross? Your estranged father from Australia. But also...
Which one of my sons was that, James?
That was Kango44.
Kango. He's always been that naughty little one, hasn't he?
It sounded like for a second like you forgot about him. You have a lot of children out there. This one from Big League Drew says, how do you explain crepuscular rays?
Big line. Crepuscular rays are basically where... Oh, is this for William?
Yeah, it's probably for me. Crepuscular rays, that's when you see rays of light through the atmosphere, I believe, right? So if you have a point of light, which you can pretend like the sun is a point of light, you would have crepuscular rays coming off that point of light. And I don't know how that I don't know how that can't be compatible with the globe. So maybe someone could explain that to me.
Yeah, this is 100% why I keep on saying that globers do not know their own model. They don't even know reality as it exists. Crepuscular rays are the effect of what happens when we see shadows getting cast by the clouds blocking some of the sunlight, which gives the appearance of sun rays in the atmosphere, all coming from the focal point of the sun itself. So without clouds, there's no crepuscular rays. That was the most basic part of crepuscular rays, is you need the clouds and you need some scattering in it that blocks some of the light to create the illusion of sun rays coming through from a single point. But it doesn't prove that the sun is as near as they think it is.
But how can that not happen on a globe?
It can. There's no reason why it couldn't, except you've got to imagine then that the clouds are also moving faster than the speed of sound in one direction and 10 times faster than an electromagnetic railgun projectile in another direction, and still appear to be just wafting in another
That's the easy part.
atmosphere contained by a vacuum of space. You have to consider the whole model all at once to
Which I do.
understand reality. If you knew your own model and you looked at reality as it exists, then you would know how ridiculous, how insane your model is.
Stop with the ad homs. It's my feelings. You're hurting them. Jeez.
This one coming in
I'm
from
only hurting your beliefs, not you. Oh.
JSS
Thank you.
Tiger. Says Iron Horse, what is the formula for circumference of a flat circle?
Oh, God, something like pi r squared, I don't know. It's been a
Almost.
while, I don't care.
Pi r squared is the
2 pi r.
area. 2 pi r.
This one from
2 pi r.
2 pi r no squared.
Chef Dylan says, William, are you related to Gene from Bob's Burgers?
He's my cousin.
I'm looking this
Thank
guy up. You don't really look
He's
like
a
him.
very attractive man.
You don't look
I
like
looked
him
him-
at all. No
I
offense.
already looked like.
I don't really
Thank
think
you.
he looks attractive either. But
Well,
this one from Big League Drew says, can a level curve? How does water find its level?
yeah, that's why I would usually not use level to describe water, because water is normally level already. I guess you do use water level when you have some kind of construction projects. You can use water to make sure that 2 points are at the same altitude. That's a very useful property of water when it becomes level. And that's how it works. Don't know how that's a problem on the globe, but maybe you do.
This one coming in from
Yeah, I do, because that picture of the horizon behind him shows anything but level. It's got a big curvature in it.
This one from, do appreciate it. Pablo73 says, flat earthers never disappoint. They're always funny. And I bet more than half of the chat actually believes that dinosaurs and Homo sapiens coexisted. Hee hee. Flat earth, I mean, Iron
More than likely.
Horse. Are you going to take that?
Iron Horse, do you
Saying it's
believe
quite-
in dinosaurs?
Quite possible, but yeah, I think most dinosaurs, the word itself means terrible lizard. Well, we've still got crocodiles and alligators and things like hippos and even elephants and all that sort of stuff. So I don't actually believe in dinosaurs as these great big reptilian things that they say we used to have. I think that's actually a cover story for the recovered bones we find that were from giant humans myself.
That's very interesting. Now I've got to tell you, folks, both of our guests are linked in the description box. We have more questions, so let me get to these as well. I think we have time. Yeah, let's jump into these. Thank you very much from Jacquina Finiline 8893 says, for Iron Horse, if the Earth is flat, how do you explain the process of polar alignment, which is required when using any telescope on an equatorial mount? If flat, it well, I'll just give you a chance to respond to that. So they say, want me to read it again, or are you good?
Yeah, no, I'm good. Yeah, basically that's exactly how we observe the stars, is they're revolving around a fixed central point. And so all you need is a single axis of rotation once you've aligned with it, and then the camera will stay focused on whichever particular star you're attracting. That works perfectly, again, for the stationary planar Earth. Not so much for the globe, because, again, the globers constantly forget that they're in an orbital motion, which is 65 times faster than their actual rotation. So when you're moving sideways 65 times faster, standing on the spot, trying to take pictures of something circling around above you, you're just going to get long streaks in the sky, not perfect circles with not a single iota of motion sideways. That should exist if the globe model were even remotely true.
You got it. This one from Pablo73. No, we got this. Okay, sorry, I'm out of it. Even Lord 7825 says, a question for William. In Germany, a scientific paper won't be published unless it's approved by an ethics committee. Does that sound like a dogma that is closed-minded?
Ethics don't belong in science, okay? We should never have an ethical committee to approve any science.
This one from Even
And
Lord
yet it does.
says, a question for Iron Horse and William. Where are the ley lines located in Earth? Are the poles the largest ley lines on Earth, with the Atlantic Pyramid being the greatest?
It's not something I've given a great deal of study into myself, but I do know that the ley lines look perfectly sacred geometric type patterns when laid over the stationary planar Earth model, as opposed to how they would exist above the spinning spaceball model.
You got it. This one. I think you got them. Want to say, folks, thank you so much for watching. It's always fun. You guys make this a blast. If you haven't yet, a couple of things. Email moderndaydebate@gmail.com if you're interested in flat versus globe debates. Apparently, people still enjoy them. We will still host them. So that's moderndaydebate@gmail.com. That's pinned at the top of the chat. But let's say you're like, James, I don't want to do that. Well, other housekeeping stuff. Check out our channel memberships, which I will tell you about when I come back in just a moment after I let our guests go. Want to say a huge thank you, though. They're the lifeblood of the channel. Check out their links in the description box. Thank you so much, Iron Horse and William.
Thank
you, Doctor.
Thank you, James.
Thank you, Iron Horse.
It's always a pleasure.
Yes.
I'll be back in a moment, folks. Stick around.
Yeah. I'm not dying. Get out of We're dancing in the street. There's nothing left to eat. We're on a winning streak. Going out in style.
Amazing. Thank you guys for all of your support. Want to say we have juicy stuff to talk about right here and now. In particular, as you can see on the hey, I'm back. That's me. But I want to say, folks, thank you guys for your support. We've got some cool stuff right now we're going to go over. So first, if you didn't know, you're like, James, I didn't know that you got these memberships. We didn't, for a long time, we never really talked about them. But lately, we're like, hey, you know what? Let's actually try to make our memberships juicier and even more amazing. And we have. So for example, there are 350 debates that some of which I had like hidden from YouTube because they were just so controversial. And then when I got to like looking them up, I was basically like, you know, maybe we should put these as members only instead of having them open to the public, because some of them are really controversial. You can see some of the people that are on the screen right now are controversial. And these debates, though, total to over 350 debates for those at the debater level. But you might be thinking, James, what are you talking about, the debater level? I'm not familiar with these memberships, so tell me, what exactly are they? So as you can see at the far left side of your screen, the spectator level is the intro level, $2.99 a month. I mean, you can't find a cup of coffee for that cheap anymore. You can't. You just can't. You can't even get the McChicken at McDonald's for $2.99 anymore. I don't think you can. Here are some of the perks involved with that, which I highly encourage you. If not for, I would say you have to be able to use the custom emojis. So you can call your friends in live chat a soy boy with the custom emoji. You will not regret it. You're going to love it. So you also get the channel membership badge, and you get immunity from slow mode for some of those really big debates where you've got like a ton going on at once. But not only that, let me show you again, going back to these three options. The second option, the middle option, is the debater level. And this is cool. The reason being, as I mentioned, there are 350 debates at the debater level that some of our most juicy, they consist of some of our most juicy debates. Also, members-only videos, member shout-outs in the old live chat as we are live. And I've got to say, let me just check on the old live chat. Exotic Spida, Big League Drew, Probing Time 666, Yazzie Rizzo 1278, and Adir Astir Fasir 1982, Big League Drew. Thank you. Colwell Alex, thank you for being a member as well. And you might be thinking, hey, what about this final level? Because I'm curious about it. I'll go back to the list of these three options. The final word is this is the juiciest one of all. And the big reason right now is because when you sign up at the final word level, you get to watch all of our DebateCon events live from the comfort of your very own home. I've got to tell you, that's the coolest thing. It says watch, you can see on the screen, it says watch DebateCon 6 stage debates live. It's supposed to be DebateCon 7. I just been slow at getting it caught up. Is that it's the DebateCon events, period. So DebateCon 6 obviously already happened, but now DebateCon 7 will be on the menu so that you can watch that live from the comfort of your very own home. Now, the cool thing is, if you received a gift membership, which many of you did. Today we had over 10 gifted memberships in the live chat. The cool thing is you're already at the $5 level. So to get to the $15 level, the final word level, all you'd have to do is put the $10 in to pay the difference, and voila, you're watching DebateCon 7 from home, and it was just $9.99 to be exact. So highly encourage you. It's going to be amazing. We're very excited about this conference, but want to say thank you guys for all of your support. We're excited about the future. We are striving to provide a fully neutral platform where it is only debates and the moderation is fair. We believe that YouTube deserves a better class of debate channel, and we're going to give it to them. Thank you guys for your support. Thanks for making this fun. Keep sifting out the reasonable from the unreasonable. This is just our beginning, though, folks. I'm expecting that within about approximately a month, Modern Day Debate will hit 250,000 subscribers, which is crazy. And we are going to celebrate it. It's going to be tremendous. I've got to tell you, hit subscribe now. Join us we are actually still small compared to where we are going. Our story is just beginning. No matter what hurdles pop up along the way, Modern Day Debate is a barreling locomotive going down the train tracks, smashing through these hurdles. Our future is bright, and that's thanks to you guys. Thank you for all of your support. Thank you guys for the fact that we're already at 245,000. Within about a month, we'll probably hit 250,000, 250,000, and from there, we are just getting started. As I said, we have a big future. Imagine someday when we're at 500,000 or 1 million and we say, wow, you remember we were back at 250,000? That was like when we were small. So thank you guys for your support. And I will see you at the next debate, which is tomorrow night, and I will be hosting it personally. So be there. It's going to be amazing. Thanks, everybody. DebateCon 7 in Houston, Texas, Saturday, January 31st. Grab your tickets now. The reason being, early bird tickets go away at midnight tonight. So grab them now. Thank you guys for your support, and we'll see you at the next debate. DebateCon 7 will be in Houston, Texas on Saturday, January 31st, 2026, and featuring some of your favorite debaters that you can come out and meet and see debating live, including David Wood, Daniel Hakikachu, Inspiring Philosophy, Mike Jones, and more. Check out the tickets right now in the description box. You don't want to miss it. We're expecting it to sell out. Grab your tickets now.